So I've been talking quite a bit about the Indian civilization, the antiquity, and the kind of corruptions made to Indian history and so on. So today I thought I'll bring out some fascinating facts of Indian astronomy. These are things that are not known, and I'm going to present two facts that I've not publicized earlier. There's a prerequisite. Anything that I'm saying today is not going to make sense to you unless we understand the problems in the narration of Indian history. So, a prerequisite is absolutely necessary before I move on. And this is the frameworks. What are the frameworks that have been imposed on historiography of India? I've talked about this at length in various talks, but it still bears some amount of revisiting. So the history of India was written by, for example, we have been very happy with our notion of history, Puranas, Itihasas. If you go to a Sthala Purana, you go to a temple, epigraphy is there, or you have genealogies of families. This has been our notion of history. We've been very happy with it. But then when the colonial people came to India, they had wanted to write a history of India for their civil servants. So they came with the idea that to show Indians as backward, primitive, stagnant, superstitious, and the British or Western Europe as forward, progressive, technologically advanced. And so that was the narration of history which they brought about. They were soon followed by the Eurocentric people, especially after William Jones found the commonality of Sanskrit, Latin, and Greek. They wanted to know why are these related? What is our relationship to the Indians? So that spawned a whole field of linguistics where a whole lot of Eurocentric notions came. And eventually they suggested the languages from Central Asia, Aryans had come from Central Asia, and those kind of narratives. Wherever the colonials were, the missionaries are not far behind. They had wanted to convert the Indians to Christianity, obviously. So they were the forefront of translating the literature. For example, H. Wilson, who did the translations of the Puranas and so on. So they came with that same bigoted narrative to try to show Hinduism as a primitive religion, superstitious, backward, and these kind of things. That's the kind of narrations they brought about. Since 1947, India has very unfortunately inherited Nehruvian socialism, which has its own problems. It comes with the idea that the past is primitive, it's backward, it is holding India back from progress. We need to throw the past away so we can have a classless future society. And it works within the constitution to produce laws and so on to suppress a dominant culture and so on. We see the effects of that even today in socialism. Since 1972, when Indira Gandhi made a pact with the communists for political survival, we unfortunately got the Marxist view also. They control the HRD sector in India to the present day, and they have their own narrations. They believe all of history is a history of class conflicts. And so they look at any social dynamics in India and say it's oppressor, oppressed, and that's the only thing you'll see anywhere. You won't see Indian philosophy, you won't see Indian accomplishments, nothing. Everything is reduced down to oppressor, oppressed. That's what I said. So these are the kind of frameworks they're done by taking history and imposing their ideology. It has led to subversion of identity. That's what we see. It's led to things like oppressor, oppressed, backward, primitive, and evil Brahmins. That too is a missionary advancement over there. So we have several structural problems in Indian history. Something that I call the enforced narration. We have something called Aryan invasion or the migration. But the evidence-based narration, which I am talking everywhere, shows that it is an out of India rather than into India. The enforced narration says Indians are Aryans, Dravidians, and tribal people, but we can show these identities are manufactured. They say the Indian civilization is recent. After the Greeks made contact with Magadha, suddenly we got the Brahmi script, Ashokan times, and we became civilized overnight. So it's a young civilization to them. But then the evidence shows that India is a pretty ancient civilization. So I open the question of how do we analyze so many narratives on history? What do we do when people come with competing narratives? There's got to be some way of analyzing this. And we need a scientific, rational, logical analysis of the data, looking at the models, methods, frameworks, and claims. And there's so much of data if you consider Indian history, whether it's archaeology, climate records, astronomy, sciences, religion, philosophy, paleontology. So many things are there. So one can take this data, look at the provenance of the data, where it came from, critique the data. Once you're happy with the data, use some kind of a model, linguistic model, archaeology model, genetics model, astronomy model. So many models are there. When you talk about models, you must have some kind of a structure, right? You have some hypothesis in mind. You have some assumptions in mind. So within those realms, you propose a model, then you have a methodology to analyze the data, then you make some claims. So then we can logically analyze what these claims are. Do they follow from the methodology that you have? Do they follow from the model that you've used? Do they follow from the kind of data you've used? Some data is high quality, some is medium quality, low quality. So we can ask these questions and logically and rationally critique the narratives out there. So today, this overwhelming trend to take the opinion of heavyweights, right? They say somebody in Harvard University said this, therefore it has to be true. Pedigree triumphs over rational thought, unfortunately. So we need to try to have a rational framework instead. So I have been pioneering a model-based analysis of historiography. I teach this in my course in Hindu University of America, where we say that we look at the linguistics model, we look at the various models that like shown over here, archaeological model, genetics, astronomy, southern Indian model, and so on. By looking at all these models, we try to see where is the evidence for the Indian civilization. So the claim out there that impacts all of us pervasively is that we have an Aryan invasion of migration theory, where bands of male warriors from Central Asia invaded or migrated to India around 1500 BCE. They effectively replaced the existing civilization and brought an entirely new Vedic religion, Sanskrit language, Vedic ecosystem. And the method that has been used to propose this is the linguistics model. The Eurocentric linguistics model has been used to do this. And we have so many assertions that have become the received wisdom. So this is now unquestioned received wisdom that somebody has given to you and you blindly go with it because heavyweight here is Max Muller, where he says that in the Chandas period, 1200 BC to 1000 BC, the earliest works, the Rig Veda was composed and so on. Mantra period is when the remaining books of the Rig Veda. Brahmana period, 800 to 600 BC, or you see all the Aranyakas, Upanishads. Sutra period, you have the Vedangas and so on. So this is what Max Muller proposed, and you find that in all our textbooks, whether it is NCRT and so on. This is the kind of narrative you find. So these are the problems. Colonial hegemony, people like the Portuguese, Dutch, French, British, with what I call the imperialistic model, which looks at Indians as backward, primitive, stagnant, and so on, along with Christian imperialism, what I call the missionary model, where the claims are Hinduism is a post-flood religion, caste-ridden, Dravidians are oppressed, Brahminical Aryans are evil. These are the kind of notions they came about. The colonial people and the Eurocentric came the idea that Sandrakurta is Chandragupta Maurya, and Sanskrit is a daughter of the Proto-Indo-European language. Aryans came to India in 1500 BCE, and so on. So many of these claims that we see arising from that. And going forward, you might think that today the world is a nice place. We don't have to deal with all these things. But unfortunately, it is a received wisdom for our academia. Our socialist Marxist models takes whatever the colonial people have said and impose on it the oppressor oppressed way of thinking. And we have the kind of narratives that we see over here. And they work hand in hand with archaeology today as well as genetics. And these have circular dependencies and they directly impact your identity and my identity, who we are as a people, who were our ancestors, whether a bunch of oppressors or whether oppressed people, who were they? Everything is impacted by the kind of narratives that come over here. So you might wonder, why on earth do we do any of these things? Why do we even talk? Why am I talking these things in a talk on astronomy? Well, the spurious narrative has got an impact on us, right? This false narrative that Aryans came to India in 1500 BC, they say these illiterate nomads came from Central Asia and they came to India, destroyed the superior civilization that was there, Harappa that is. And then these illiterate people are running around India with caste, cow worship and all these kind of things. And India had to wait until Magadha made contact with the Greeks in 300 BC. Suddenly we became civilized according to them. Then they say, yours is a young civilization. You haven't had enough gestation time for building up knowledge. So if you see advanced knowledge in astronomy, math, medicine, they say it probably came from the earliest civilizations like the Greeks, Babylonians, and so on and so forth. So in this model, what they say is things like this. Aryans brought Sanskrit into India. Brahmi came from Aramaic script into India from the Levant. They say Turkic Muslims brought us culture, cuisine, architecture, music, and civilization. The British got us science, technology, rational thought. Math and science came from Greece, astronomy from Babylon, and today they say even bhakti that was taught to us by St. Thomas, and things of this nature. So we see that there is a denial of agency. We don't have agency in narrating our own history. This has led to a gross distortion where we are kicked around, basically by these ideological forces that I talked about, and they tell you who you are rather than you having the agency to control what exactly it is. So I call it a criminal distortion of the history of the Indian civilization, all the anchor points of our chronology, every aspect of Indian knowledge systems and identity is impacted. If you take any book, Western printed book on history of science and technology, India is a footnote. India is merely a footnote over there. This is the absurdity to which this narrative has gone, where the accomplishments of our ancestors are erased. So, with this as a background, like to talk about astronomy itself. So, Indian astronomy, yes, our scholars have known about it for a long time, all the way from Kashmir, maybe Afghanistan, and beyond up to Tamil Nadu. We have had a common astronomical heritage. But when the colonial people came, they wanted to translate Indian works and learn about it. So, the first few people like Cassini, Lee Gentle, Euler, Bailey, Playfair, Davis, these people spoke very appraisingly about Indian astronomy. They were wowed by the chronology, by the mathematics. They said Indians are outstanding in what they've done and so on. And then came along William Jones. William Jones is the person who started the controversies on the linguistic basis. When William Jones came along, this Aryan invasion theory also came along. Then said, wait a minute. Is Indian astronomy as ancient as it appears to be? Maybe not, because the linguistic model is decreeing that it's got to be 1500 BCE. So all the people are shown in red are people who are speaking against the antiquity of Indian astronomy and proposing that Indians have learned from Babylonians and Greeks and so on and so forth. So we see these are the kind of problems. The issue is that Indian astronomy shows far greater antiquity than suggested by linguistic theories. So that is the background. So with that, we come to today's talk itself. So that's a big prelude so that you understand where all this is coming from. So I would like to show amazing facts from Indian astronomy, which is obviously not talked about in any texts and so on. And I'd like to first talk about what are the things that Indians observed. When I say Indians, our ancestors, what did they observe? All the way from comets to galaxies. I put an exclamation mark. So you must be wondering what on earth. So Indians have observed, for example, solar, lunar eclipses. We have as far back as Rig Veda, you have Rishi Atri, who's observing a total solar eclipse. And this promptly led to a lot of derision among all the socialists and Marxists and missionaries who said that Indians believe there's a demon called Rahu who swallows the sun and Ketu. They're so superstitious and nonsense. See, the problem is if you don't appreciate the metaphor, your understanding remains at a pedestrian level. It remains at a pedestrian level where everything becomes a mythology. But if you have the key to unlock that wisdom, suddenly the wisdom of the ancients becomes apparent and you become enlightened, right? So unfortunately, the people who called it as a demon and so on, they were pretty misled over there. Aryabhatta showed us what it is. Aryabhatta showed that the orbit of the moon is inclined at 5 degrees to the ecliptic. Ecliptic is the sun's path. On the sun's path, 5 degrees offset is the moon's path. Because of that 5 degrees offset, whenever you have an eclipse, there's a window when an eclipse can happen, solar or lunar eclipse. And he called these ascending and descending nodes as Rahu and Ketu. So Aryabhatta was the one who explained this and made it clear that no, it is not a demon. This is a name, metaphor given to these kind of things. And he had formulas in Aryabhatta to say what is the length of Earth's shadow, what is the length of Moon's shadow, when will there be an eclipse, and what is the length of what is the duration of the eclipse. He had formulas for all of those things. I'm not going to read those things, but basically Aryabhatta has got formulas to do these. Amazing, amazing. What else did Indians observe other than eclipses? They also observed a phenomenon called precession. Precession is something I talked about at length in the past. The Earth, in addition to doing a rotation in 24 hours, in addition to going around the sun in 365.24 days, it is also precessing where it is pointing to the axis of rotation that is tracing a slow circle in the sky. And it takes approximately 25,700 years to complete. And we have evidence of Indians who have observed this phenomena and made measurements on that. And I'm going to talk about this a little later, so I won't spend too much time on this now. Indians also observe transits. Transits are when the inner planets, things like Mercury and Venus, when they go across the face of the sun, as far as we are, from our perspective, those are called transits. So Indians perfectly knew about these transits, and this picture that I've shown over here is one that I took in 2016. This little black dot over here is Mercury. Mercury going across the face of the sun. And can you now imagine Indians were able to estimate when this would happen, and they could even talk about it. They had parameters they could refine based on these things. In the Western experience, it is only after Galileo had the telescope in 1610, Kepler got enormous data. Only then Europeans were in a position to predict a transit of Venus. It was the first in the Western world, whereas it was routine in India, where people knew exactly when these transits happen and so on. Indians also observed planetary conjunctions. Conjunctions are when two planets come close to each other. You might remember recently, maybe 2 years back, Saturn and Jupiter came very, very close together. You might remember that. So this is called a yud. They call it as a yud. And here is Surya Siddhanta is explaining the conjunction of various planets and stars and so on and so forth. Indians also observed lunar occultation. From our perspective, when the moon obscures a star, typically a nakshatra, that is called a lunar occultation, right? In fact, in my TEDx talk, I've explained the love story of Chandra and Rohini, saying why did Chandra love Rohini more than the others is related to this occultation phenomena. So here is the moon occulting Kritika in 2006. A picture shows that. Indians also observed comets. Comets were called Dhumaketu. And there are so many of them. If you see in Rig Veda, Ramayana, Mahabharata, Parashara Tantra, Vriddhigarga, Varamira, even Sangamira Tamil works also talk about these. Now, the problem is we don't know what these comets were because comets have got such long periodicity, so we cannot estimate what these comets might have been. But after 12th century, we can reliably say, yes, this comet is this, and so on and so forth. But these ancient ones, we have no idea what it is. Now, that opens my big question. Did Indians observe the Andromeda galaxy? Andromeda galaxy is the biggest galaxy to us, at least nearby to us, and we can actually see it with a telescope and so on. So the question is, did Indians observe Andromeda galaxy? So the Andromeda galaxy we know is 2.5 million light years from Earth. It's a pretty big one, 150,000 light years. It's the same size as the Milky Way. Now, in the year 964, a Persian, Al-Sufi, he observed the Andromeda galaxy and called it like a cloud. It looks like a cloud. And after 1600s, then after the telescope was made, Western Europe was able to observe these galaxies. Initially, it was assumed to be a nebula. They had no idea from 1600s what exactly is this entity that we are seeing over there. They had no idea because they thought until 1930s, they thought that the entire universe is just Milky Way. And they had no idea that there were galaxies outside the Milky Way. So they thought these nebulous objects were gases inside our own galaxy, inside our own universe, Milky Way. It is only after Hubble in 1920s, he did some measurements of some Cepheid stars. He had a 100-inch telescope. With that 100-inch telescope, he could see the stars in Andromeda galaxy. And one of the stars is what we call a standard candle. With that, he was able to confirm that it is more than, his calculation was wrong, but he said it's more than 90,000 light years away. Once we knew it's more than 90,000 light years away, then people knew from 1930s that yes, there are galaxies just like Milky Way. Our universe is not just the Milky Way, but there's far, far more than that. So that is a little history on the Andromeda galaxy. Andromeda is known in the Greek tradition. The Greeks did not observe the Andromeda galaxy, but there is a constellation of some stars, and we can have this art and so on and so forth. In the Greek stories, there was a maiden who was chained to a rock, and a hero comes and saves this maiden. They get married, and so there's a nice little delightful story over there that talks about Andromeda. This is the Greek art for that. Now, it's amazing that we also have a story on the Andromeda constellation. Now, not the galaxy, but the constellation itself. I think this is the backstory of Mahabharata itself. All of us know about Sharmistha. She was the daughter of a Daitya king, and her friend was Devyani. Devyani was the daughter of Rishi Shukracharya. And one day, these two girls go and they have a bath, and the clothes get mixed up, and she wears the queen princess clothes, and the princess gets angry, and so Sharmistha pushes Devyani into a well, and she leaves. But then she's saved. Devyani is saved by Yayati, and later she marries him. And then the sage Shukracharya comes, and he's about to curse the king because his daughter behaved so badly. But as atonement, he sends his daughter Sharmista to work as a maid for Devayani. But then when she's working as a maid, she also has an affair with Yayati and has got kids by him. And when that happens, obviously Devayani is very, very angry. Yayati is cursed with premature old age because he likes to enjoy. He said, no, you'll have old age, you won't be able to enjoy anything. Then he gets a boon saying that if one of your sons takes on your old age, then you can regain your youth. And he asks one by one his sons, who's going to take my old age? Eventually, his youngest son says, I'll take it. So he gets 1,000 years of youth. Once again, he enjoys. In heaven, he's got a problem with Indra. There's a quarrel over there. Indra pushes him from Swarga. So he goes down and starts falling down. And that is the story. So in the Indian tradition, we identify the Andromeda constellation as Devayani, and there's a big W constellation, which is Cassiopeia. That is the other lady here called Sharmista. And this little picture shows you over here, this Cassiopeia, the big W in the sky. This is Sharmista. And this constellation over here, where you saw the Greek maiden chained, that same one is Devayani over here. And between them over here is a little cloud, what is shown here. This is the Andromeda galaxy. Now, the Greeks did not talk about it. Okay, they only saw this huge constellation. If you look at in a very, very dark skies, not in New Delhi, not in any urban place, go pretty far, maybe 100 kilometers away, and on a moonless night, if you look at if you know where to look exactly, then you'll see a cloud. Andromeda looks like a very, very dull rain cloud. You can see to the naked eye. If it is very, very dark, you can see it. You may not observe it initially because if you can imagine a rain cloud at night, how is it going to be? Even the daytime rain cloud is dark, right? At night, how will that rain cloud look? Just a very, very dull cloud. That is how it looks the size of a full moon. That's the size of a full moon is what you see Andromeda galaxy. So what we are seeing in the Mahabharata is that there is a discussion where a rishi called Ashtaka, he is curious to determine what this object is, and he describes it as a dark cloud. So over here you see Yayati, he's falling from the region of the celestials, and beholding him, Ashtaka is asking, who art thou, falling from on high? And he also says, are you like the sun emerging from dark masses of clouds? Everyone is curious as to what is falling, deprived of consciousness. So this is an astronomical object that is not like anything else. We can see stars, we know what stars are, we see comets, we know what comets are, we see planets, we see all these objects, but this is a strange entity. So this story is now telling that the rishis were curious to know what is this object that was over there, and they are asking questions about that. Going further, now, let me see if I can read this over here. So he goes and says, you look like a young man, handsome, you have a celestial garland. That is very interesting, celestial garland. Where have you come from and where are you going? Are you going down to the earth? Yayati says, yes, I've obtained a boon from Indra. I must fall upon the earth. We know that the Andromeda galaxy is on a collision course with Milky Way galaxy. In 2 billion years, it'll be meeting with the Milky Way galaxy. Just an amazing fact. I don't think it's linked over here, but to me, it's amazing to say Yayati saying, yes, I'm coming to the earth. And eventually, Ashtaka says, are there regions for myself to enjoy in heaven or in the firmament? Yayati is saying there are many regions, as many as the number of animals on earth. Then one more rishi over here is asking the same question. Are there worlds for me where I can live? And Yayati is saying there are so many worlds that even if you dwell for 7 days in a world, there are so many, countless of them. So it is an expression of the rishis that this object that we are seeing has got so many stars and worlds twirling around that. That speculation has come out over here. I don't know if speculation is the right word, but then they have, in some way, they've understood that that's what it is, and that is what they said over here. This is exactly how you'll see Andromeda through a telescope. If you just see through a telescope, you'll see this. If you naked eye, you're going to see it as a dark cloud. Then there's an interesting aspect over here, locating the galaxy. Ashtaka is asking, what are those 5 golden chariots next to you? Will they take you to heavens and so on and so forth? And this is a picture that I've taken of the Andromeda galaxy. This is the galaxy. And these are the 5 yellow kind of stars. These are probably in our own galaxy, but these are stars over there, part of the constellation. Looks like it is a chariot that is pulling him along. And so this helps us to locate that indeed this is the Andromeda galaxy. There are 5 stars over there. And this is how we identify it. So he says over here, What are those five golden cars that we see? Yeah, it is saying yes, it will take you to wherever you need to go, and so on. So, bottom line, Indians observed the Andromeda galaxy. Yayati is the Andromeda galaxy in the Indian tradition, and the story is a backstory of Mahabharata. Devyani is identified as the Andromeda constellation. Sharmista is the Cassiopeia constellation. In between them is their husband Yayati, who is the Andromeda galaxy, described as a dark, cloud like object with countless worlds heading towards Earth, driven by five chariots. This is the world's first description of a galaxy. And it's amazing to see that. It also shows that Greeks had copied Indian stories. The Greek story of this maiden chained to a rock and saved by a hero is the same as the Indian story. Devyani is pushed into a well and is saved by Yayati. So we see copies of Greek story. Greeks are copying Indian stories. All right, was that fascinating? Yeah. Could you have imagined? Could you have imagined that Indians would have seen a galaxy? In our modern world, we didn't even know what a galaxy was till 1920s or 1930s. And here you have Yayati saying that there are many worlds out there for you to enjoy. And even if you spend 7 days in each of them, there'll still be countless of them to enjoy. It's amazing, amazing. When I saw this, I said, wow, this is outstanding. This is exactly what this is, based on where Sharmista is, based on where Devyani is, and based upon the description given over there. All right. The second fascinating fact of Indian astronomy is measuring this entity that I called precision earlier. So, what is precision? Briefly, I talked to you about it. This Milankovitch cycles, there are three of them. Milankovitch is a Serbian scientist in 1920. He said that these cycles of the Earth are linked to climate change and all of those kind of things. So the orbital cycle of the Earth around the Sun goes from circular to elliptical in about 100,000 years. This axial precision, this is the precision, you can see the axis of rotation that is tracing a circle in the sky. That takes about 26,000 years. We also have tilt. Axial tilt is happening, and that takes about 41,000 years. So for us, the most important thing is axial precision, because with that, we can start making measurements on when something might have been observed. Because Indians, at the point of vernal equinox, they would say, here's a nakshatra, that vernal equinox. It's a sidereal measurement because a star is referenced over there. Because of precision, that point at which that vernal equinox has changed over thousands of years is going to change. This is that star over here, but after 1,000 years, it has moved on. So we can now work backwards in time and say, when was that star at that equinox position? So it's very, very important for us to understand that. So there was a pretty odd statement from David Pingree and the others who said that Indians did not know how to measure the skies. In his thesis on trying to say Indians copied from the Greeks and Babylonians, he said that they incorrectly copied from the Greeks and Babylonians. Both Hugh Bauer as well as David Pingree mentioned that. So I'd like to now present some facts that show Indians were very much in control of measurements of the sky. And one of the first one is from Colebrook himself. Colebrook is talking about Goliyantra. Goliyantra is some kind of an instrument to locate the stars. And he's saying the manner in which they explain observing the places of the star, he's saying Surya Siddhanta hints briefly that you should frame a sphere, examine the apparent longitude and latitude. This is in Surya Siddhanta. Going on to in Siddhanta Shiromani, it is saying how to construct this Goliyantra. And basically, it's an armillary sphere. And the observers instructed to look at a star Revati through a sight fitted in an orifice at the center of the sphere. And then having found the star, adjust it and make some measurements, and you can make a call on what is the latitude, longitude, with a transformation also. Because the measurement done over here is not the direct measurement. To go to something called ecliptical coordinates, Indians have the mathematics to do that. It's a little complicated. The point is that Indians had something called an ecliptical coordinate system. To get the coordinates in that, they had to do some calculations. And Colebrook over here is talking about all those things. He says that the latitude so found is apparent, being the place intercepted between the star and ecliptic. And then he says how it has got to be recomputed so that you get the right one. So I'm calling this as proof of observational astronomy, understanding that coordinate transformation is needed to get the true latitude and longitude way back. In Bhaskara II's time, and maybe going back to Aryabhata's time, we have that. We have more than 5,000 years of instruments. We have evidence of that. If you go to Harappa, We have in 3000 BC the water clocks. Water clocks were used to measure time and so on. Vedanga Jyotisha, that is also talking about water clocks. If you go to Aryabhatta, he's talking about various yantras over here that are used to measure the skies. Aryabhatta also had a globe. He had a globe constructed using which he could see the shadows of the earth, shadows of the moon, and all of those kind of things. So he used that. By the time he came to Varahamihira, he also had graphic calculations, not just these things. He was making graph calculations. When you come to Brahmagupta, he's got a whole lot of other instruments. Bhaskara one talks about a circular platform, the graduated circumference. I did not know what this was, but then when I went to Harappa, I saw the, sorry, Lothal, I saw this. In Lothal, if you go to Ahmedabad, you see this, that there is a brick platform circle. Nobody knows what it is. But the minute I read this, I said, wait a minute, this is an astronomical observation. This is the same thing that Bhaskara has talked about. So Bhaskara is talking about the circular platform, and somehow this is used for some astronomical measurement. And Lalla, Mahendra Suri, and others. So we know that for over 5,000 years, Indians have been using instruments to measure the skies. And we also know that Indians knew the cardinal points. Where is the winter solstice, summer solstice, vernal equinox, autumn equinox, reference planes, horizon, ecliptic, equator, celestial poles, north, south, east, west, and the zenith. These are all the things Indians knew about, and they formed the mathematical coordinate basis system to locate stars, latitude, longitude, and things of that nature. Today we have something called equatorial coordinate system to locate stars. If you got a modern telescope, it might have the equatorial system with a go-to kind of a function. So this coordinate system rotates with the Earth. So you can position a star in some numbers, it will stay fixed. Another coordinate system is the altitude azimuth. Ancient Indians used the ecliptic coordinate system. In the ecliptic coordinate system, this is now the plane of the sun. That is the ecliptic. So if there's a star in the sky like this, there's a way to reference that. And the zero longitude position was vernal equinox. This is the vernal equinox position for zero longitude. And because the vernal equinox position keeps changing with precision, we have to recompute the Indian calendar at each time. We have evidence of that. We have evidence that Mrigashirsha, that was the vernal equinox in 4000 BCE. Rohini, that was the vernal equinox in 3000 BC. So every time the reference point changed, we have evidence that the Indians had to recompute their calendars and have a new system. So because this is the kind of system they were using. I talked to you about precision. Precision is such an intricate thing that takes 25,700 years to complete. So did Indians observe that? That was a fascinating fact I promised to tell you. Well, this is there in the Surya Siddhanta. Surya Siddhanta is saying the circle of asterism liberates 600 times in a great yuga, Chatur Yuga. That is to say, it moves west 27 degrees, returns to the old place. Then in other words, he's talking about a sine wave. It goes from 0 to 27 degrees, comes back to 0, minus 27, back to 0. This is what he's saying. Then Professor M.L. Raja from Avinash Research in Coimbatore, he explained what this is. If you take a yuga has got 4.32 million years, a Chatur Yuga has got 4.32 million years. So the data in Surya Siddhanta is saying it completes 600 revolutions. So if you divide these, that means for one revolution it takes 7,200 years as far as Surya Siddhanta is concerned. Then we call this Ayana Chalana. So if you take the 600 revolutions, this 27 degrees multiplied by 4 segments is 1 segment, 2, 3, 4 segments. Multiplied by 60 degrees, to convert it to minutes. Multiplied by 60 to convert to seconds. Divided by the number of years, you get 54 arc seconds in a year. This is an amazingly accurate measurement that says how much does the precision change in 1 year's time. 54 arc seconds. To give you an idea, if you extend your pinky out into the sky at arm's length, that is about 1 degree of the sky. If you extend your your entire fist, it is about 15 degrees in the sky. Now you imagine that you are measuring 54 arc seconds, not degrees, arc seconds. Now you get an idea of how advanced ancient Indians were to do this. You might wonder, what were the other civilizations doing? Could they also have measured precision, and what was the number? Well, Surya Siddhanta, I'm not going to put a date on this. It said 54 arc seconds a year. Parashara Siddhanta, which Professor Iyengar has dated to 1400 BC, that repeats the same number. I think it is from Surya Siddhanta. Vriddhigarga, he says 36 arc seconds in a year. Abhyankar has called this out. Hipparchus the Greek in 120 BCE copied the same figure as Vriddhigarga, 36 arc seconds a year. In China, in 307 current era, they measured it at 72 arc seconds in a year. Aryabhatta, he had it as 48 arc seconds in a year. So what does this mean? 54 is an overestimate. The correct figure is 50.2. 54 is an overestimate. Aryabhatta did underestimate at 48, but the error is much less, right? It's just 2 degrees away, 2 arc seconds away. Then the Al-Batani, the Arabs copied Surya Siddhanta exactly. So they said 54 arc seconds a year, and so on. By the time we come to Bhaskara II, he's got a much better number, 48.6 arc seconds. Pathani Samanta Chandrasekhar in Odisha, he made naked eye observations. He did not have the benefit of Western sciences or learning or anything. He schooled himself entirely on works of Aryabhatta, Bhaskara, and others, fashioned his own instruments, and he measured it to a staggering 49.179 arc seconds a year. Why is this important? Because this says how our ancients could do these things. The methods of Pathani Samanta Chandrasekhar are an exemplar to us. How our ancients did it with just bamboo instruments and things of that nature. Very, very interesting. With that, I'd like to close this out with the absurdity of Professor Pingree's assertion. Pingree was a professor in City University of New York. He's no more now. But he's written a lot on Indian astronomy with the idea that Indians copied from the Greeks and the Babylonians. So he says over here about Varahamihira, how he's observing that there is Ayana Chalana over here. He's talking about that. Then he uses words like that. It is not unreasonable to suppose the idea of trepidation or precision was introduced to India by the Greeks, though the parameters chosen by the Indians are their own. You see the convoluted language over here with so much of uncertainty and other such things, giving him escape clauses, but then he's not sure. And even the Indians have their own parameters. So, on what basis do you say Indians copied from the Greeks? We have such a long history of learning over here. So, along with that, I also want to show is this? Yes, so there's evidence of ancient mathematical modeling for astronomy, because if Pingree says Indians only copied from the Greeks, we have evidence going far beyond that. In Lagada's Vedanga Jyotisha of 1400 BCE, there's an amazing rule over here called the rule of three. This rule of three is in Rig Vedanga Jyotisha and Yajur Vedanga Jyotisha. And those of you who are familiar with high school algebra recognize this from here. A by B is C by X. X is the unknown quantity, cross multiplication, and you get the quantity X, right? Vedanga Jyotisha is saying this, but it's saying you must apply this again and again. I've given an example here. If you have a planet at some point, that planet is moving at distance delta S in a time delta T. You have water clocks, right? You can measure all these things. Then your question would be, in maybe 2 days' time, where is that planet going to be? So to compute that, this is the formula you use. But then Vedanga Jyotish is saying that is not enough. You can apply this again and again and again, iteratively. Engineers call this iterative prediction, right? A linear iterative prediction. You can predict up to a year if you want. There could be error in it, but you could predict it. That is the point. So this is amazing that Indians were doing this in this time frame. We have evidence that linear is not enough. If you take a star out there and do a linear interpolation like Vedanga Jyotisha is doing, that will not work because the sky is curved, right? You need to have spherical coordinates. So we have evidence that Indians had trigonometry for this. Western claims Hipparchus is the father of trigonometry. Utter nonsense, because this is what they had, Ptolemy and Hipparchus, which is a chord table. A chord is not trigonometry. Trigonometry is right angle triangles like you see over here. This is then Surya Siddhanta. Surya Siddhanta talks about trigonometry. They did not have trigonometry. That is what we see over here. And we have evidence that Indians worked towards high accuracy. Aryabhatta had linear interpolation formulas. Bhaskara had this kind of a formula. By the time we come to Brahmagupta, this linear is not enough. He's got second order interpolation to compute the sign values. And by the time we come to Kerala School of Mathematics in Madhava, he has got infinite series for sin x, cos x, tan x. This is showing to us that Indians were not stagnant in their thinking. They were not saying Shastras are frozen in time. Somebody, Aryabhatta, said that, so I'm not going to do anything else. No, they were observing the skies always and saying, hey, there's an error. If I use this formula, there's an error. How can I make it better? Where did the error come from? They were able to model it, they were able to visualize it, they were able to make it better and better with innovations. This is what we see. So clearly from Aryabhatta, from Lagada, all the way to Aryabhatta, Bhaskara, Brahmagupta to Madhava, we are seeing that the quest for accuracy has been there in Indian astronomy. So with that, we can go to the third fascinating fact. How accurate was the planet modeling of ancient Indians, right? I'm going to show you extraordinary accuracy which ancient Indians accomplished in planet modeling. And once again, we start with an absurd statement from David Pingree, 1976, the recovery of early Greek astronomy from India. David Pingree had such an audacious statement that he said, if we don't know something about Greek astronomy, all we have to do is read Indian astronomy because Indians copied from the Greeks. So we can recover Greek astronomy from Indian astronomy. That kind of a statement is really outrageous, but that's exactly what he said. This whole paper is about that. And he says over here, but if Aryabhatta did not observe, how did he arrive at this mean motion that is correct for his time and so on? And he says answer is extremely simple. He used Greek tables and that is how he was able to do it. So he just made a presumption that Aryabhatta did not observe and therefore he got correct numbers because he copied it from the Greeks. And another place over here, he says the Indians did not know about planets because Vedanga Jyotish is not talking about planets. Vedanga Jyotish is concerned with a whole lot of other things. Then he says in the epics Ramayana, Mahabharata, planets appear in astrological context, that they're devtas and things of that nature. So he presumes that Indians had no idea about planetary theory and other such things. I'd like to rebut that and what I'm going to tell you presently. So this is from a paper by Professor R.N. Iyengar in 2008. He's talking about the astronomy of Parashara in Parashara Tantra over here. He's saying this Parashara has got to be dated to the same time of Vedanga Jyotisha, which is around 1400 BCE. And take a look at the translations. Over here, he's saying Jupiter traveling 2¼ nakshatras in a year leads to good crops. This is what Parashara says. But over here is mathematical data. It is saying that in a year, Jupiter is going to travel 2½ nakshatras. We know each nakshatra is 13 and 1/3 degrees, right? So you know exactly how much Jupiter is going to move, and that's given you the orbit of Jupiter right there in Parashara's work. And the same thing he says over here about Mercury. Here he talks about Saturn. Saturn's path through the 27 nakshatras is for 28 years. That is a mathematical data right over there. So with this mathematical data, Aryabhatta might have used it for his numbers over here. Similarly, you see for Venus cycle according to Parashara's 591 days and so on. So Parashara has given a whole lot of data for mathematics which could be used by further researchers. When did he live? He lived approximately in 1400 BCE, much before the Greeks came on the scene. We have got this data and Aryabhatta must have used this. And by the time we come to Surya Siddhanta, in Surya Siddhanta we have statements like in a Yuga, the revolutions of the Sun, Mercury, Venus are 4,320,000 and so on. A whole lot of data, mathematical data is given in Surya Siddhanta over here, which you can put into a table. I'm not going to bore you to death by reading all these things, but by the numbers that we have here, we can also compute the mean daily motion. This is what we have. The mean daily motion means how many revolutions in a Mahayuga divided by the number of days in a Mahayuga multiplied by 360 degrees, you get how much does this body move in one day's time? What is the mean daily motion? So Indians always had these constants. What is the daily motion of some entity? They were able to do that, right? Even if it was for the application of, let us say, having a Jataka done or some such thing. You need to know how much will this planet move from one point to the other and things of that nature. And so this is the kind of intricate mathematics that Indians knew that allowed them to do all these kind of computations. Aryabhatta is also talking about the mean motion of planets, and we can see that over here. You can compare Aryabhatta's numbers to Ptolemy's numbers because there's a claim that Aryabhatta copied from Ptolemy. Well, you see the numbers are different. They're slightly different. And for the moon, they're exactly the same. But for the sun and for others, there are differences over here showing that these are Aryabhatta is not copied from Ptolemy. Aryabhatta must have taken numbers from Parashara and he must have made his own corrections on that. David Pingree starts with an assumption saying maybe Aryabhatta did not observe. He must have copied it from the Greeks. So everything's a knee-jerk reaction, right? If you want to claim something, you say they copied it from the Greeks. That's what you see here. Indians had the epicycle model for the solar system. So it looks like Earth is at the center, the moon goes around around Earth. You have Mercury that goes around Earth, but it also goes in a circle by itself. Same with Venus. And the sun obviously goes around the Earth over here, Mars, Jupiter, Saturn, and others. So this is called the epicycle model. Indians had two epicycle model. One is called a Manda, the other one is a Shigra. Shigra was a fast epicycle, Manda was a slow epicycle. So using intricate mathematics, they could track the movement. Indians also had a model that was contracting and expanding epicycles. Okay, so it is not a simple epicycle model, but it'll contract and expand at times. That is what is shown over here. So we are seeing in this work a dynamic tradition of innovation. We are seeing evidence of spherical geometry, trigonometry, measurement devices, prediction, tracking, mathematical equation modeling, error correction, approximation, parameter fitting. All this evidence is there if one understands this epicycle model that Indians are doing this. And this is a paper from a person called Anil Narayanan, who tried to compare the Greek model and the Indian model. He wanted to see the Greeks had an epicycle model, and that's led to the claims that Indians copied it from the Greeks. But then Aryabhatta and Surya Siddhanta is also talking pulsating epicycle model. Anil Narayanan has compared these two things. So he says the pulsating epicycle is a unique feature of Indian astronomy. The Greeks did not have that. So if you look at the Greek model, it is a constant epicycle, whereas for the Indians, it was a pulsating epicycle, as you can see. So the Greeks, like he says, a constant radius one. And he's looked at the error in both of these things. And he shows that the Indian epicycle model has got far greater accuracy than the Greek model. So what has he done over here? He's showing the error in the solar longitude. If you're saying that the sun from the vernal equinox point, it is going to come back to this, if you have the daily mean motion, right? After 1 year, it must come back to vernal equinox point. If it does not come back, there's an error. And how much is that error is what he's doing over here. And he says that he computed the error for the year 100 and for the year 2000. And the Greek model is dotted lines, and you can see the error is very great. Indian model is constant, this continuous line. You see the error is much smaller. The amazing thing is, this was also studied by a colonial astronomer called Brennand in the 1800s. So Brennand looked at Surya Siddhanta at the parameters given there, and he said that the parameters of Surya Siddhanta for the mean motion of the sun seems to be most accurate in 3000 BCE. This is what Brennand himself said. 3500 BCE. Anil Narayanan did further simulations to find out where is the least error in the model, and he kept cranking back in time. And as you can see over here, the error in 2000 is very great. It is falling in 100. It goes to 2000 BCE and so on. Eventually, he's come down to 5000 BCE. This little line that you see here, that's 5000 BCE. In 5000 BC, Surya Siddhanta's model had the least error. What sense do we make out of this? Because our mind has been programmed to say that people were primitive in 5000, 7000 years ago, Stone Age kind of people. But then here you are, the mathematical model, this is also incredibly accurate in tracking the mean motion of the sun and things of that nature. So it is simply mind-boggling to think that, yes, there could have been astronomical knowledge at that point, which is that great. So it's a far greater accuracy than the Greek model. So with that, I'd like to open the question, how ancient are parts of the Surya Siddhanta? I only say parts of Surya Siddhanta because Surya Siddhanta has been rewritten several times, several people. But we have evidence there is a core component of Surya Siddhanta that is very ancient. And we can measure that antiquity also. So that's what I like to say over here. How ancient is that? Again, I'm invoking Anil Narayanan's work to do this. It's a fascinating fact again. So Surya Siddhanta has got a model of the sky, right? It's got latitude, longitude of the various nakshatras and so on. But if you compare those numbers to today's numbers, they are greatly in error. And we can wonder why on earth is this error so great? And obviously precision is one of the reasons. So you could have longitude and latitude. So two of them are there, right? So if you take a look at all these nakshatras, Ashwini, from Bharani, Kritika, Rohini, and all these things, Surya Siddhanta has got a brightness. It measures, just like today astronomers measure the magnitude of the relative magnitude of the stars with some number. Surya Siddhanta's got number 3, 5, 3, 2, 1. This is an estimate of Surya Siddhanta and how bright that nakshatra or the star is. And it's got a longitude, Surya Siddhanta longitude, Surya Siddhanta latitude. And the modern longitude, modern latitude. If you look at just the first number, longitude is 8 degrees in Surya Siddhanta, modern longitude is 34 degrees. Latitude is 10 degrees, the modern one is 8.5 degrees. So clearly, Surya Siddhanta's measurement of the nakshatras was done at an exceedingly ancient period of time, and Anil Narayanan set out to figure out when is the error minimum. He identified which are the quantities that will vary, time obviously, including something called proper motion. Proper motion is, well, the stars are not stagnant in the sky, right? All the stars in our solar system, along with the sun, is going around the galactic center. It takes approximately 230 million years to go once around the galactic center, right? So the movement of the stars as it is going around is called proper motion. Now, all stars are not going at the same speed, like a running race. Some of them are going pretty fast, some of them are going slow, and so on. So from our perspective, some star might be going pretty fast. We can't make out the three-dimensional velocity, but we can make out the angle. From our reference angle, how quickly is the angle where the star is changing. That angle is called proper motion. He also sees the ecliptic obliquity will change, the nodal location will change, vertical motion of the ecliptic will change. So he set about to write a program to do this. And in his program, he found that if he cranks it back in time to 7500 BCE, which is over here, that is when the error became the least. The error between Surya Siddhanta and where our modern numbers are. If he wanted to find a match in time, understanding these quantities are changing, he had to go back in time to 7500 BC to get that error to a minimum. So this is an amazing thing that talks to us about the antiquity of the Surya Siddhanta, for example. In the same Surya Siddhanta, there is a star nakshatra called Swati. Swati is the Greek name is Arcturus. If you want to find out Arcturus, you can first look for Saptarishi. The tail of Saptarishi points to Swati, as you can see over here. So Swati is one of the fastest stars in the sky in proper motion from our perspective, and it has got a motion of 2 arc seconds in a year, like is shown over here. This is a proper motion. This is 2 arc seconds in a year. Now, Swati is off by 1 degree compared to the Greek records. Even the Greeks had observed Swati, Arcturus. If you look at their Greek records and the modern record, and at the rate of 2 arc seconds a year, we can crank back in time and say the Greek observation was made 1800 years ago. However, Swati's latitude position is off by 6 degrees compared with Surya Siddhanta. Surya Siddhanta has got a number that is off by 6 degrees. So if you try to compute that, 6 degrees times 60 minutes times 60 seconds divided by 2 arc seconds, you get 10,800 years old observation. Somehow, Surya Siddhanta, the oldest part of it at least, or maybe it may not be the oldest still, but an old part of it has got observation that goes back to 8000 BCE. So this is staggering to just think about some of these antiquity of some of these measurements. What it is telling us is that Indians as a civilization have expended great amounts of time to observe the stars, to map the stars, to measure the stars, and to pass on that information to posterity. That is what we are seeing in all of these things. Okay, with that, antiquity, it is the next obvious thing and the fascinating facts. How ancient are some of the astronomical observations that Indians have made? So I've just got a curation of a few of them. There are many, many, many of them. I just selected a few. You might have seen this in my earlier talks too. This is Vedanga Jyotisha. Vedanga Jyotisha, several people tried to date it. Weber, Pillai, William Jones, Tilak, Colebrook, and others. And the closest was Dikshit, who came to 1400 BCE. And the dating of that was done because it talks about winter solstice occurring when the sun and moon come together in the Dhanishta Nakshatra. Sun and moon coming together in winter solstice in the Dhanishta Nakshatra. It does not happen today. Today, we don't have winter solstice in Dhanishta Nakshatra. So that means you can crank back in time. Remember, I told you about precision, right? So you can have a mathematical planetary software today that can crank it back in time and do that. This is one such simulation that I have made. So what you see here, these circles are the projection of Earth's latitudes and longitudes in the sky, and they become celestial coordinates in the sky. So this here is the celestial North Pole, that is 90 degrees. Then these circles are celestial latitudes, right? So 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. Zero is the celestial equator. On Earth, it is a regular equator. On the sky, it becomes celestial equator. So this is now going south, -10, -20. This is -23. So when the sun goes to -23 degrees, we have the winter solstice, right, in the northern hemisphere. It has gone to the southernmost point. So when the sun has gone to the winter solstice, we are seeing the longitude over here. This is Dhanishta Nakshatra. So this happened in 1440 BCE. So this way we can date Lagada and Vedanga Jyotisha to this very, very ancient period of time to 1440 BCE. All of you know the story of Dhruva, right? Dhruva is a very delightful and sad story too at the same time. So Dhruva's father, he gets tired of his older wife. He marries a younger woman, and Dhruva's unwanted, right? One day he tries to sit on his father's lap, and the younger wife pushes him away, saying, "You have no place on this dad's lap." Little boy is inconsolable. He's crying and tells mother, "Where is my place in the universe?" And she says, "It's all karma, don't worry," and all those things. But he does not want to hear that. He goes off and he meets Saptarishis. They teach him how to do dhyana. So he does dhyana for a long time. He's meditating. Eventually, Vishnu comes and asks, "What do you want?" Then he is in a state of bliss. He does not want anything. So Vishnu says, "Okay, you'll become a motionless star in the sky. And even the Saptarishis will go pradakshina around you." Okay? And he says, as you go become a star in the sky, your unhappy mother, Suniti, she will also be a star next to you. This is what is there in the Purana story that talks about Dhruva. Now, that is an indication that Dhruva is a motionless star. The axis of rotation of the earth is pointing at Dhruva, right? So here is where we are today. This second picture that I shown in 2022, this is our Dhruva today. And we observe that there is no companion for Dhruva here because of precision, because where we are pointing to is changing over time. So we had to go back thousands of years to figure out when exactly was the story of Dhruva made. And we crank it back to 2800 BCE, approximately 4800 years ago. Then we see Thuban. Thuban was a star at that time, and there's a tiny star nearby, a companion. That is Suniti. So this is exactly as in the Purana story that is saying that your mother will be close to you. That is only possible in this time frame. In no other time frame do we have a nearby star to the polar star. So clearly, the Purana story is that ancient. But if you believe Wendy Doniger and the others, Puranas are written in 300 current era and things of that nature. How on earth did they know about this kind of a story? So this is the problem. Many of our texts have got astronomical phenomena that is hinting at the antiquity. And this is one clear such thing, saying the Puranas, in the Indian context, Puranas are all written by Vedavyasa. So approximately 3000 BC or somewhere around that time is when many of these things were made. Then there is a story, not a story, but an account in Shatapatha Brahmana. Rishi Yajnavalkya is telling the Vedic practitioner how to find the east direction. Where is the east direction? You might say common sense, right? Wherever the sun is rising, that is east direction. But that is not true. The sun is going all the way to -23.3, then all the way to +23.3 across Uttarayana and Dakshinayana, right? So where is the east direction? Is it here, 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 and here? That's not true. Only on the day of the equinox, the sun is exactly on the celestial equator. That is true east. So Yajnavalkya is telling, in order to find the east direction, you see where Kritika is. Kritika does not move from the east direction. You can light your yajna, your fires under Kritika. That is what he says. So he's referring to heliacal rising of Kritika Nakshatra at the equinox point. So that turns out to be over here, the simulation over here. What you see here is a horizon line. Again, this is the North Pole. And everything below, this is the ground line basically. You have the day here, night above. So imagine that it's early morning, it's still dark. The Vedic practitioner has a ritual bath, comes out, it's still dark. He sees all that. Kritika is over there. So there's Kritika over here. If you count this from 90, 80, 70, 60, 50, 40, 30, 20, 10, this is 0, the celestial equator. So when Kritika, he said, first sees Kritika over there, and about half an hour or 1 hour later, the sun appears over the eastern horizon, washes out Kritika. You can't see it anymore. But he's got a straight line. He's got 2 points. He knows that's a straight line. So he'll arrange all the bricks over there and start the Homa fires over there. So this is something that was noticed by several people, that Tilak and others, that this is an archaeoastronomical observation in this. And the date obviously is 2982 BCE. Then there are several references to this ancient epoch in Indian works. The Puranas are talking about Kali Yuga. Aryabhatta, Surya Siddhanta refer to this epoch. Pulisa Siddhanta, Brahmagupta, Al-Baruni, they all refer to this. Aihole temple epigraphy, that refers to this. Cassini, he got some tables from, astronomical tables from Thailand by a French a visitor over there. And those tables, which are called Table of Siam, seem to have the longitude of Ujjain, longitude of Benares, and they couldn't make sense out of that. So this man sent it off to Cassini in Italy, who was a mathematician, and he said that it has got an absolute calendrical reference to 3102 BCE, midnight of February 17th and 18th. Later on, other people like Playfair, Bentley, Colebrook, Burgess, they studied the same phenomenon, Surya Siddhanta, and confirmed this. It turns out to be a conjunction of planets, sun, the moon in the Revati nakshatra. So this is what we refer to as the traditional start of Kali Yuga, and this is in Surya Siddhanta. The reference to this Kali Yuga episode is over here, and the simulation shows it over here. You see that February 18th, 3102 BCE, Sun is over here, Chandra is over here, Guru, which is Jupiter, Shukran, Venus, Revati Nakshatra is over here, which is Zeta Piscean, Mangala is Mars, Budhan, Mercury, and you see this Shani, Saturn, slightly off, but they're all clustered more or less in this place. So this is the traditional start of a Kali Yuga, and it is referenced to in many, many works. The question in your mind is, how on earth is a 3102 BCE referenced in a Vedic text, whereas Max Muller has told us that 1200 BC is when the Rig Veda was composed? We have a problem over here. I hope you're seeing that. Very, very big problem. The received wisdom of Max Muller does not seem to be in the astronomical measurements. We all know about Aditi. Aditi is the mother of gods, along with the co-sister Diti, and they married Rishi Kashyapa, and you have the Daityas, Devas, they are the progeny, and the path of, and Bhagavad Gita says, Uttarayana is the path of the Devas, and the Pitrus is Dakshinayana, and all these kind of things. So Aditi is a repository of everything good, truth, generosity, magnanimity, purity, beauty, renown, and other such things. But I am fascinated by a particular episode in the Aithriya Brahmana. So this is the Aithriya Brahmana translated by Martin Hogg. And in the second chapter, we see a very curious statement over here. It says the sacrifice, which is basically the yajna, this went away from the Devatas. The Devatas were unable to perform any further ceremony. They did not know where it had gone to. They said to Aditi, let us know the sacrifice through thee. Aditi said, let it be so, tatastu, but I will choose a boon from you. What is that boon? She said, all sacrifices will begin and end with me. This is what Aditi says. This is very cryptic, right? But Balagangadhar Tilak read this first and said, this is an astronomical measurement over here. It is an instance, always Indians have been doing yajnas or festival celebrations based on celestial calendar. If the celestial calendar has changed, and why will it change? Precision. Over thousands of years it changes. Then you don't know when to do your yajna. So it reflects the confusion of ancient Indians. Ancient Indians are so confused, they did not know when do we do our sacrifice, because the star is not where it's supposed to be, nakshatra is not where it's supposed to be at vernal equinox and things like that. So they have reset the calendar to Aditi. Aditi is saying the new year will begin and end with me. Do you understand that? The new year begins and ends with me. Vernal equinox, that's what he's saying. So it is a resetting of the reference point to Aditi. That is what is recounted over here, very, very cryptically. So Aditi is associated with the Punarvashu Nakshatra. Punarvashu Nakshatra has got two stars. One is, let me show it here. This is Diti. This star here is Diti. Below that is Aditi. Collectively, they're called Punarvashu. In the Greek tradition, it's called Castor and Pollux. Okay, those are Castor and Pollux. So vernal equinox at Punarvashu Nakshatra, if you crank it back in time, this happened in 6000 BCE. Again, staggering period of time, but it reflects that at that period of time, Indians are already looking at the stars, when to do the yajna, when to do the festivals, already confused, they've reset the calendar. Very, very nice evidence that shows that. Surya Siddhanta is talking about a great conjunction, the Mesha Rashi. And this is the clustering of all these planets that you see. It is in February 22nd, 6779 BCE. So amazing antiquities there. I've only curated a few names, dates here and there, but there are many, many, many more of these things. That brings me to the sixth fascinating fact I'd like to tell you. And this is the antiquity of the story of Surya. And the punchline is not there. The punchline is there's an unexpected validation that came just last year. I'd like to share that with you. So we know the story of Surya, right? So the Rig Veda, Markandeya Purana, Matsya Purana, they're all talking about this. So Sanjana marries Surya, we know that, and they have their children, Yama, Yami, then and so on. One fine day, Surya is so bright that Sanjana can't bear it. So she abandons her husband and goes off to the cooler regions, and she leaves a shadow Chaya in her place. And one fine day, Surya discovers a deception. Hey, you're not my wife. Where is my wife? And she says she's gone to the cooler regions. And cooler regions means southern regions, basically. And so Surya goes off in search of his wife, meaning Surya also has gone to southern region. He's gone there. And he finds that she's taken the form of a horse. So he too takes the form of a horse. This is shown in this painting over here. And the Ashwini Kumaras are born because of that union at that point. And we have several instances of Ashwinis appearing in the Rig Veda. For example, they appear as Ushas. Ushas is the goddess of dawn. So over here in Rig Veda 8.9.17, it says Ushas awaken the Ashwinis and start the day. So Ashwinis are appearing at daytime for their share of the Vedic sacrifice, right? That's the intent over here. And we are seeing that they're born in the winter solstice. Why winter solstice? Because Surya goes to southern region. If Surya goes south, it's winter solstice in the north, right? He's gone to southernmost region. So they appear with the sun at dawn for heliacal rising. So we have to see when did Ashwini Nakshatra rise along with the sun when it was winter solstice. That is what we have to do over here. If you crank it back in time, you get a staggering date of 7200 BC. That is when the sun is heliacal rising over here, Ashwini Nakshatra is here, and this turns out to be 7200 BC. This is discovered by Balagangadhar Tilak and repeated by Abhyankar and so on. So I know many of you are uncomfortable looking at this and wondering what on earth can we have such ancient measurements? After all, Max Muller has told us some things and NCRT textbooks tell us something else. So can we have had all these things? I got a very, very unexpected validation of this last year from this Nature paper. This Nature paper is talking in 2022, obviously, a cosmogenic radionucleotides reveal an extreme solar particle storm in 9125 years ago, or approximately 7176 BCE. I put this at 7200 BC in archaeoastronomy, but this event is 7176 BCE. What are they talking about? By the way, that was not the only paper. A second paper also came in Nature, and this paper is the earlier one was looking at radioisotopic quantity, radioactive isotopes. This one is looking at tree rings. The tree rings are revealing two strong solar proton events in 7176 and 5259 BCE. That is the second paper in this time frame. So we know that the sun goes through maximum and minimum sunspot activity. Over 11 years, it goes through max min. And whenever there are sunspots, it typically would result in coronal mass ejection, CME events, when sometimes if it comes towards the Earth, it can disrupt the satellite communication and all of those things. We frequently have this kind of events happening. So this is a coronal mass ejection, for example, when a huge solar flare is ejected from the sun, and it might, if you're unlucky, it comes to the Earth, right, towards the Earth. So I wrote something on this, which you can read up on medium.com, once upon a time, 9,000 years ago. The biggest solar event we have known is something called the Carrington event. This Carrington event happened in 1859. So the storm was so big, it's the largest solar flare recorded. It resulted in a heavily ionized atmosphere. Basically, when the solar storm hits the Earth, we have got magnetic lines of force right around the Earth. So these take the charged particles and conduct them to the North Pole and the South Pole. That way saving the rest of us over here. So what happens is these particles collide with that upper atmosphere, and there are several isotopes and radioactive particles. That's how we get aurora displays. All the auroras in the North Pole and South Pole. That's how we get the northern lights and things of that nature. That's what you see in this animation over here. This resulted in such a heavily ionized atmosphere, telegraph lines could be operated without power. In fact, there is an operator in Portland, Oregon, who was working with this operator in Boston, and they did not turn on the batteries at all. This is 1759. They were doing that Morse code, right? Morse code kind of thing. They could do it without turning on the power. They could operate it. Over a period of 2 days, September 1st, September 2nd, in 1859, this happened. And the coronal displays could be seen in latitude as far south as Hawaii and China. Normally, the northern lights display can only be seen at the polar regions, but this was seen in Hawaii. That tells you how big this event was. So this is one of the biggest events that we know about. And like I said, the solar flare, what happens when it comes, crashes into the earth, a whole lot of things happen. Billions of tons of super hot gas containing charged particles. So we can detect this because these things go into the North Pole and the South Pole because of the magnetic lines of force. They are preserved in Antarctica as well as the polar ice regions. They preserve the radioactivity. So scientists can go and drill these ice cores and take them to the labs, and they can actually go back in time like a time machine and figure out. This is one example of the ice cores from Antarctica, and scientists are evaluating these things. And in this paper, it says that way back 7176 BCE, all these graphs, these numbers that you see, suddenly these numbers are shot up. And they say that's one of the biggest ones, maybe 10 times bigger than the Carrington event. That is the estimate. Carrington event is one of the biggest ones that we had today. Scientists today say if the Carrington event happened today, the entire world will lose power for more than 1 year. All the electrical grids will be gone, transformers would have burst, and you wouldn't have so many transformers to replace it. The whole earth will take 1 year or so to recover. So this giving you a size of that event. This event is said to be 10 times greater than the Carrington event. And all these pictures that you see, I'm not going to describe these isotopes over here, that show a huge jump in 7176 BCE. So what is the relevance of Surya's story? Carrington event was 10 times smaller than 776 BCE. I am saying that the storm could have been observed as increased brilliance of the sun for a period of time. The people who went through Carrington event, they were saying that even at midnight, they could read newspapers and things like that. It was so bright. And if you go to places like Australia and places like that, they said that everywhere we look, there was brilliance. The lights keep changing, brilliant lights would keep changing and so on. So this kind of an event could have been anywhere you look. The earth would have been so ionized, you have seen a brilliance of the sun. Sun would have been super brilliant. Ancient Indians have observed this. 7176 when it happened, Indians have observed this and remembered that sun was super brilliant for a period of time. And after some time, the solar storm subsides, and they have said that Vishwakarma came and chopped off some of sun's brilliance, and then they had marital bliss because Sanjana came back again, right? So that is a story that we remember, but it's pegged to this 7176 BC by two studies, tree rings and ice cores. So what have we done? We have independently derived archaeoastronomy. For the last 100 years, Tilak has been saying this. For the last at least 6 years, I have been saying this. Last year, these two papers came out and provided an independent validation of, yes, there was a solar event that could have been this bright. Our Indians have seen that, have recorded that. So how old is our Purana story now? The story of Surya, how old is it now? So we have got cultural memory going back to 9,000 years, completely opposed to what we have been told in our textbooks and things of this nature. I'm coming to the end of my talk. Another fascinating fact, Indian and Greek stories, right? You take any Greek story, I will show you a parallel with a Purana story. There'll be slight changes here and there, but there's a parallel with that. So this is the story that I often talk about, the missing seventh sister. In the Greek tradition, the Pleiades were the virginal companions of the goddess called Artemis. Artemis is the protector of the girls. And one day, these girls are having a bath in a lake, and Orion is a massive hunter and is a serial predator also. So he sees the girls, he's enamored by them, and he starts chasing them. And these girls are running away from him, and he's chasing them and so on. Artemis is furious. She goes to Zeus and says, "Protect my girls." But Zeus does not care. So eventually, Artemis has Orion killed by a scorpion, and that's what the story says. And Zeus makes both Orion and Pleiades as stars in the sky. This is the famous Orion constellation. It looks like a hunter with a bow here, right? Belt of the hunter and so on. Pleiades is a tiny kite-like object, very, very small kite-like object sitting over there. Through a telescope, you find how brilliant it is. Really beautiful to look at it. So the problem is there are 7 stars in the Pleiades constellation, at least 7 that we can see, but only 6 can be seen. Where did the 7th one go? That is the question. So the Greek story says Merope, the seventh sister, had an affair with a mortal man and she hid her face in shame. And because she hid it, we can't see her. That's what the story says. Would you believe that we have an exactly similar story in India? And can you guess what it is? Yes, absolutely, the Kritikas. So in the Markandeya Purana, we see a story over here. So one day the Saptarishis are having a Homa and Agni is officiating priest in the Homa. And when he's doing the Homa, he's looking around and he sees the Saptarishis' wives, beautiful women. They're so beautiful, he's enamored by them. And then he feels so ashamed. I'm looking at a married woman and he feels terribly ashamed. He goes off and does tapasya because he's not done a good thing. But in the process, he's neglected his own companion Swaha. So Swaha has got unrequited love, right? So she knows the weakness of the Agni. So she takes the form of each of the Saptarishis' wives. She assumes their form and seduces Agni. And each time she seduces him and she tries. The seventh sister was Arundhati. Arundhati's chastity is legendary, right? So she couldn't take Arundhati's form. Arundhati is too powerful. So only six sisters. That's how Skanda was born. So six-headed Skanda is born over there. Kartikeya is born. And when he's born, there's great disturbance in the three worlds. And the forest dwellers have seen this illicit romance, right? They've seen all this Agni's dilly-dallying over here. So they go and they tell the Devtas that we saw all these things. It's basically this. Now the innocent Saptarishis' wives, they are all innocent. They've done nothing. They feel so ashamed. They leave their husbands and they become the Kritika Nakshatra. They go off and become the Kritikas. The seventh sister stays back and she's with Vashishta. Vashishta Varundhati is the binary pair in Saptarishi constellation. So what you're seeing here in the Greek story and the Indian story, the theme is an illicit romance or some kind of a thing over here. Merope is hiding her face. Here it is something else. So there are slight changes from the Greek to Indian, but we always see the same. Even in the story of Sharmista, Devyani showed Andromeda constellation. They too have a story of a maiden is chained to a rock and the hero comes and saves and marries her. In this case, Devyani is pushed into a well. Yayati comes and saves her, right? So very, very similar stories are there. This shows how the Greeks have copied a lot from Indians. One little thing I'll explain and perhaps stop after that. In the in the Greek tradition, there is a star that is called Antares. Antares is called anti-Mars. But if you ask the Greeks or you study the Greek literature, you'll have no idea why is Antares called anti-Mars. The answer comes through Indian knowledge. Indian knowledge can tell you why it is called so. So I wrote this some time back. So Ares was the name, a Roman name for Mars. Antares derives its name from anti-Ares or anti-Mars. Ancient India's nakshatra, it is Jyeshta. Jyeshta is the elder. It is same as the Antares. The ruler of Mrigashirsha nakshatra in the constellation Orion is Mangala, which is Mars, a combative association going back almost 4000 BCE. So if you take a look at the changing of the calendar system from Mrigashirsha, there is a story of how Rudra goes and kills this Prajapati over there because of some issue over there. It goes back to that particular association. Jyeshta and Mrigashirsha nakshatras are 180 degrees apart. This is Mrigashirsha in the eastern horizon. This is Antares, which is Jyeshta in the western horizon. So as this one sets, this one is just rising the sky. There's 180 degrees difference. So this anti-business is basically, this is dying when this is rising. So it's an anti-behavior. And because Jyeshta is associated, the ruler of Jyeshta is basically Mars. That is the reason why we see this. So Indian knowledge explains why the Roman star is called Antares. But if you look at Roman literature, you'll have no clue about that. So very interesting to see that. So I started out by talking about a prelude. A prerequisite for any of the things I was talking about was to understand historiography in India is corrupted by five frameworks: the colonial, Eurocentric, missionary, socialist, academia, and Marxist. They have imposed their ideologies on the history of India, leading to the narratives that we have. According to them, we are Aryans, Dravidians, and tribal people. According to them, the Aryans came around 1500 BC, either through a war, invasion, or a migration. According to them, we were uncivilized for a long time. According to them, 300 BCE, when Magadha made contact with the Greeks, we suddenly became civilized. According to them, all our knowledge has come from Greeks, Babylonians, Egyptians, and others. This is who we are. And this is in line with their ideology that they want to destroy the old order. In India, the old order is Hinduism. By destroying Hinduism, they hope to bring in their so-called utopian fantasy of a classless society. So that's what we see in Indian constitution, Indian laws. Every one of them have been framed by socialist Nehruvian policies, and that's what we see to the present day. Okay, so I talked about that and how the deep history is wrong. Linguistic methodology is used to uphold the narratives. It does not align with evidence from many fields. Today, I've only discussed astronomy, but it can be falsified using genetics, can be falsified using archaeology. Archaeology in the country today, in Birana, Rakigadi, and other places, we are seeing dates going back 9,000 years. For example, in Birana, we got carbon dating going back 9,000 years. That's well in line with the dates I've been telling you in astronomy, right? Astronomy, we said 9,000 years. Birana, well, radiocarbon dating is showing 9,000 years. So it's not fantastic. We have been told a lie. We've been told a big, big, big lie. That's a problem. And we discussed some fascinating aspects, or at least I call it fascinating, of Indian astronomy. The big thing I revealed today was Andromeda galaxy is identified as Yayati. I don't think this identification has been made, but by looking at this literature, we can make out. We talked about Indian planetary modeling and accuracy, the very high accuracy of measurement of precision by ancient Indians. We talked about the antiquity of some parts of Surya Siddhanta. We talked about the antiquity of some astronomical observations. We talked about the solar flare in 7200 BCE, how it is remembered in India as a story of Surya, Sanjana, and Ashwins. I had to tell you two more things in that story, which I neglected to tell you. In that story, when you have so much of radioactivity, beryllium especially, that is known to cause cancer, that is known to cause all kinds of problems. In the story, we are told that Yama is limping and his sister Yami is shivering all the time. Ashwins are born. Ashwins are traditionally healers, physicians, healers of the gods, and so on. So when they are born, the solar flare is over and everything is fine. So there's a lot of symbolism in that story that we can decode one by one and figure out more and more things. Very interesting. So the antiquity seen in Indian astronomy clearly discredits the Aryan invasion migration theory because that constrains Indian chronology to merely 1500 BCE. But if you break those chains and throw them away, suddenly you have the intellectual freedom to consistently look at the evidence and say, yeah, genetics, archaeology, astronomy, everything showing an ancient civilization. Mr. Max Miller, you're wrong, out of the door. All right. So with that, I come to the end of my talk. So thank you very, very much for your.
Let's start first with a little comment. Professor Kapil Kapoor, we've been recording him a lot at our office these days on Indian knowledge systems, and very interestingly, on one of the last talks, he mentioned that all the shuttle darshanas in Indian knowledge systems were means or they came out of interpreting or understanding the Vedas. So when you mentioned today, where is East? And that was actually to conduct the Yajna. So that actually points to the same conclusions, which was very, very interesting for me. So before this, the Vedas were okay, something else and Indian knowledge systems exist independent of those.
Right.
So, that was one observation. I don't know if you want to comment.
Yeah, certainly. There's the very famous Indian philosopher Surendranath Dasgupta. His opinion was that Ayurveda, health, was the reason for most of the Nyaya Sutras. The logical statements that we find in Nyaya Sutra, the killer application was medicine. He said that medicine, you always want to know, does he have this condition or that condition? Did he eat this food or that food? There's a logical chain of thought, right? So he said that Nyaya Sutras, probably the inspiration was medicine. That's where it came about. So yeah, we see applied knowledge systems all the time. In my classes, I often say perception and inference, pratyaksha anumana, came with Rishi Kannada, right? Vaisheshika. Vaisheshika, once people have internalized that, all the Siddhantas that we have, all the medical works we have, show clear evidence of trying to understand the reality out there, measuring the reality, making sense of the reality, and then writing out what is out there. So we see the evidence of that all the time. In fact, I say that Western Europe had logic and rationality as long as they had contact with ancient India. The minute it became Christian in Constantine Christianity 330 current era, It was okay with Constantine, but his successor was Theodosius. Theodosius is like the Taliban of today. They burned the so-called pagan libraries, the temples, everything was destroyed to Christianize. They adopted the theological framework. In theological framework, you shall not question. Questioning is blasphemy. Your only role is to obey. So when Europe went through that, they went to the Dark Ages. When Europe was ultimately able to get rid of the theological construct and go to the so called age of rationality and enlightenment, they once again rediscovered these things through Vedanta and other works, including perception inference. All of a sudden, you see this explosion of thought in Europe after that. So clearly, the darshanas are our guideposts on how do we live, how we look at the reality and understand things.
Thank you. I have three questions so that I don't, I'm all over the place. I read them out. So you seem to suggest that many, if not all, of our Quranic stories are perhaps metaphors for astronomical phenomena. So you mentioned Rahu Ketu earlier on a WhatsApp chat I've discussed with you. The much maligned by Muslims, Brahma raping his daughter.
Yes.
Yes. I've discussed with you. Then I'm assuming stories of Shiva and Kartikeya and all observations. And at the same time, we have real geographic sites in India, Shakti Peethas, Jyotirlingas, Tirupati, which are all intertwined with such stories. So how do we reconcile, these two dichotomical ideas?
Okay. As far as the reconciling, that's a tough one. But in the first aspect, Indians always had the philosophy as in the macrocosm, so the microcosm. As in the skies, so here. They saw these great cycles, the rhythm of the universe. So they lived life according to the Rita, the rhythm of the universe. So everything in the Indian context has been that. So they try to make sense of the stars. They try to make sense of that. That's why Yayati was an aberration. The IIT is an aberration. It's a cloud over there. They have no idea what it is. You see that. So that's why they discuss what is the nature of this entity and things like that. So I would say that Indians sought to see the patterns in the sky and map them down to the earth. And that's why you have so many metaphors over there. They look at something over there, they have a metaphor for life. There is a moral, a wisdom that they intend to communicate to you, but the inspiration might have come from somewhere over there. That's why we see it repeatedly. The story of Bhasmashura, right? Touch your hand while dancing, you're going to fall dead. He fell dead on the day of Uttarayana. So it tells us about Uttarayana, Dakshinayana, and things of that nature. So the correspondence to geographical entities, the Shakti Peethams and things like that, I'm not very sure. I'm not very sure what it is. There's certainly some strong reasons why ancient Indians have done that and tied these stories to these geographical places, but I'm not very sure what it could be.
Right. So there are 7-8 chroniclers currently of Indian chronology or Indian Itihasa, if you like, including yourself, Vedi Raja, Leshok, Nimrod Raja, many of them, maybe more, 10, 12 of Srikant Raligiriji. A lot of them, including perhaps yourself, are seeming to use some sort of NASA software to check for astronomical observations, go back in time and see if that was, So why are we reaching different conclusions? If it's so fact-based,
So
is it the software itself, or is it that we have different starting points to look at the same data?
You're right. All of them. There are several things over here. Different people use different software. I myself use Telerium, and somebody might use Voyager, somebody else might use something else. Most of these things have a mathematical core called VSOP 87, or it might be even later than that. But this is the core that tries to predict these things. Many of these mathematical softwares are polynomial approximations to the mean motions of the stars and other such things. It has got a region of validity. You cannot use it beyond 10,000 years in the past, 10,000 years into the future. You can't do that. Even if you did that, the accuracy is not so great that you can get a day when something happened. You can't do that. So there's some problems with the software itself to start with. That is one. Second, whenever we say something is a piece of data, we have to do the diligence. We have to critique the data. What is the provenance of the data? Where did the data come from? If it came from Griffith's translation, is Griffith right? Then you might like to see some other, if you don't know Sanskrit, that is, you might go to see somebody else's translation, and then see, are they all talking the same thing, or is there a difference in that phenomena they want to represent? For example, somebody might say that something is spoken of in Sanskrit in the past tense and not in the present tense. So if I assume it is a present tense, then I make some assumption for my archaeological astronomical measurement. But if it is something that happened in the past, then I can do something else. I know I'm talking in riddles, but this has got to do with two of the people you named and one of the battles on the dating. So researchers will do what they have to do, but I think we will have to do the diligence. We'll have to see the data, provenance, validity, assumptions, are they right? Are the interpretations right? The text itself could be different. You have one edition of Satyapada Brahmana, maybe in Saraswati Mahal library they have another edition, and that is different. That same thing is different. That verse itself is not there. You see what I'm saying? So you need some kind of critical edition to see, is this there most of the text, or is it an interpolation? So many things are there when you see the data validity.
So is it also a matter of all of you sort of getting together on deciding at least to some sheet anchors say, I mean, the variance right now is really high, 25,000 years to 18,000 to 7,500 BC or something like Surya Siddhanta.
Right.
Because there is Mahabharata and all of that going on, but
Right.
even just looking at Buddha Nirvana, which is not too far out, and could we gather together? Is it a matter of that with some facilitation, or is it actually that this is going to be how it is? Connected question there. Sorry, then that last question before I hand over is the very interestingly you mentioned Yuga cycle, right? And Vedvi Rajaji recently mentioned in one of the last Sandon talks that the Yuga cycles itself have changed from 5 years to 20-year cycles. Now that was very fascinating for me. I don't know if he's right or wrong. I know I'm not in charge of that. But this is new kinds of data which keeps coming up. And all I'm wondering is that if he's arrived at some conclusion, is there a way for other scholars to validate whether this is true or no? Is it a matter of sitting in a common room?
I think in the ideal case that should happen, but in the reality is that most researchers tend to be strong-minded. So and there's an unfortunate aspect of doing research. They have strong ideas because they've spent years and years doing something, and they're convinced with their drishti, with their insight. They know this is what it probably is, and they have something to tell you. So when you come and contest that, it is a question of, hey, have you walked the same path as me to see what I have read or what I have learned? So that's the question. So in a scenario like this, we have problems. We have problems if you try to date the Itihasas. I have not gone there. None of my talks have talked about date of Mahabharata, Ramayana, because it's a contentious area. Not because we have few researchers here and there, because some people might take data point 1, 2, 3, 4 and come up with a date. For example, 1700 BC, saying with Iron Age, Professor Arna Iyengar, for example, Jijit Ravi, and others say these things. Some others might say the clustering is around 3102 BC, 3100 BC. That 2 or 3 dates there itself, but people like Vedvira Arya, Jayashree Sarnath, and others might cluster it over there. People like Nilesh Oak and also who he's got the data from, they might refer to 5100 BC and so on. So point is to different datas in order to advance their claims, and we'll have to see, can we make sense of all of the data? There'll be differences of opinion. If you propose that this is the date on which I'm making this assumption and therefore doing this, somebody comes and says that interpretation is not right. That's a strong-minded statement, right? Now you have to contest whether that statement is right or wrong, and you're defending your thesis. Other man is saying, no, that is wrong. This is the correct way of doing it. So I think we should not even go there. Itihasa dating for me is not ready yet. I don't think we should do it. People should continue researching. We should continue to put the claims on the table, and people should continue studying them. But I don't think we've seen the last word over here yet. To me, there is so much other than that to talk in the Indian civilization without even going to Ramayana, Mahabharata.
So my main question here is one pertaining to what you call as Uttarayan or Sankrant. Like we still have, like I've seen that even right now, a lot of people believe that the Uttarayan is associated with Makar Sankranti.
Mm-hmm.
But like you said, because of this Ayanams
Mm-hmm.
or the Nirayana or the precession of equinox,
Mm-hmm.
it is not so. Because Uttarayan occurs at December 21st,
Right.
whereas the Sankranti occurs in January 15th.
Right.
Maybe at one point of time,
Right.
as per the Sayana system, they coincided.
Right.
There's still this widespread belief, which
Yes.
even I feel that learned people, acharyas also follow, and so that this is one thing which I wanted to ask, and second thing which I wanted to ask was like if the event which you mentioned related to solar flares, and if Ashwini is related to the ending of the solar flare, which marked the great sigh of relief for the inhabitants of this galaxy, sorry, inhabitants of the solar system, then my question is like, did this event happen at Gamma when the sun was in Gamma Aries, which is, as you might be knowing, referred to as Ashwini, right?
Mm-hmm. Mm-hmm.
Is there any astronomical evidence for that? Or prior to that, prior to this event, what was that star called as, which was the beginning point of the.
So if we are celebrating Makar Sankranti, no problem. But if you call it Uttarayana, yes, we have a problem. That is the issue. So because of precision, things have changed. So if somebody celebrates Pongal and says that Pongal is done at this time, Makar Sankranti, it's no biggie, because it is what we're celebrating is Makar Sankranti. That is the Sankranti you want to celebrate. So I think like you said, at some point in the past, they too coincided. Uttarayana coincided with this, but now obviously it does not coincide anymore. So we have to be careful about that. Regarding your second question, yes, these flares are not for years together. They happen because a storm that comes from the sun, right? It's a huge storm. It's like, I think it's estimated to be about 4 billion nuclear bombs, things like that, that's headed towards the earth. So it's like a wave that comes, a huge wave. And this wave, the 1859 wave was just for 2 days. September 1st, September 2nd of 1859. This is 10 times greater than that. So naively, we can say, yes, it lasted for about 20 days or 10 days. So in the 10 days time, maybe we were continually hit by a storm. Maybe it rose up, went to a maximum, then fell down. And that would have happened when the sun was in the Ashwini Nakshatra itself and remembered by the ancients in that particular manner. Please introduce yourself.
So, I'm Chetan Pandey. I'm a software engineer and a digital archivist of rare manuscripts, including Jyotish.
Wonderful.
I can give you at least 1,000 ebooks in Jyotish, about Jyotish.
Wonderful.
In Sanskrit itself. So, when we read about the zodiac signs, you see Aries is Mesh and the symbol is the bull, and they all correspond to the Greek originals. Like, whatever. So, are you saying all these are actually Indo-Indian adoptions of the Greek by the Greeks, not the vice versa, which is the contemporary. There has to be one source, because 12 zodiac signs can't have the same names. Vrishchik is exactly like that, and all that. So can you explain?
If you believe in the Western assertions, Indians got the Rashi model from the Greeks.
Okay.
If you believe in that. But if you read Subhash Kak and other works, he shows clearly that the Rashis are derived from the Adityas, 12 Adityas. They are the ones that led to the Rashi, eventually the Rashi model. And Indians have been following this. The Rashi was meant for the path of the sun. It's 30-degree segments, 12 of them, right? 12 times 30 will give 360. So they're following the path of the sun. In 1 month of 30 days, it approximately goes through one Rashi. So in order to track the sun's movement, Indians had the Rashi. Adityas, 12 Adityas, so that is the reason for that. On to this. Now, Subhash Kak has given a number of reasons why Indians did not copy from the Greeks, rather the Greeks have got it from India. Additionally, if you take a look at Ptolemy's works, Ptolemy had an additional constellation, Rashi. He had a 13th one. You may want to take a look at it. Look at Ptolemy's constellations, zodiac. He had a 13th one in his a snake kind of thing in his constellation. So it's not the exact same. If Indians had borrowed it, why did they not take the snake? You see what I'm saying? So all the research which I've been doing shows that the Greeks probably were not as advanced as ancient Indians. And all evidence is showing that they borrowed from India rather than Indians borrowing from the Greeks. I just finished a workshop in Nalanda yesterday, where I was showing that there's so many Greek historians who have talked about India. Not one Indian is talking about the Greeks. So many Roman historians talking about India, nothing this way around. So what does that mean? Ancient India was like the United States of today. USA is a parochial country because it is so rich and arrogant, right? It's rich, it's got everything it needs over there. It doesn't need the world. So the average American has got no idea of the geography outside America. Whereas the rest of the world, we study just about everything. Ancient India was like that. We didn't need anything. People would come to Nalanda, people would come here, come and learn Sanskrit, come and do these things. Indians had no need to go out anywhere. So we don't have any remembrance of any of these visitors or any such thing. But they got deep histories. I've shown in my workshop more than 13 to 14 Greek writers who wrote about India. We don't have one, not even one. The one little thing we have is in Manimekalai. Manimekalai is a Tamil works where it talks about Yavana ships coming, beautiful ships coming to Tamil Nadu coast. But we don't know what Yavana is. Is it Ionian or what is it? Because Indians call anybody from outside as Yavana. So there are a lot of circumstantial as well as other evidences that we can bring forth to say that the Greeks probably were not as advanced as Indians were, and it is from India that this information has gone to Greeks and they have used it many ways. All the stories that I talked about, these are not recent. These are going to India to the kind of time frames I talked about, 2000 BC and earlier and so on. In the Greek tradition, it happened in the Minoan times and other times. This is when it happened. And if you remember recently, about 2 years back, they uncovered a palace in the island of Crete, the Knossos Palace, where they restored the frescoes on the wall. And one of the frescoes is showing the langur, Indian langur monkeys. And what were the langur monkeys doing in Greece? They're not native over there. These belong to India. So clearly it shows that in the time frame we're talking now, 1600 BC, that's a time frame for this palace. 1600 BC, they already had contact with India. So they were taking Indian ideas wholesale and recasting them into their own. That is what we are seeing over here. So this, I just give you one. There are many instances to show
You are
that.
saying India did not borrow anything from the Greeks.
I don't
as far
think
as
so.
Astronomy and astrology. is concerned.
Not at all. I don't think so.
The trouble is that the way we have been like to get some state patronage. What kind of patronage do you get? And does it frustrate you? Because this
Me? There's a personal questions.
by you I mean
Yes.
this entire body of work.
So
And this is very frustrating because
thank you for that question. Thank you for that question. It turns out that there's zero patronage from anybody at all. The entire burden of the Indian civilization's narrative has fallen on private citizens. And there are a whole lot of them, whether it's Vedveer Arya, whether it is Nilesh Oak, whether it is Rajaram Mohan Roy. So many people are the ones going out there and upholding this narrative. The government or institutions like ICHR or others have absolutely nothing to do with this. They're not even interested reaching out or any such things not happening.
it would die.
Unfortunate. It's only our interest and our passion over here. Over the last several years, every trip I made is on my own money, out of my money. Every day of my vacation I spent here, going and giving talks. Thanks to my wife, who's agreeable with that. But Rahul will tell you, yesterday I was in Nalanda, and the previous day, before that I was in Vellore Institute of Technology. In the next 5 days, I'll be in Rishigud University here in Sonepat. And after this, time to go back to USA and start working. So the private citizens are doing this, and at great cost. At great cost. There's no support from anybody.
So, my first question is that you said that the story regarding Aditi, you've dated it to 2800 BC.
600. Dhruva was 2800, yes.
2000. So, I just wanted to ask, is there any archaeological substantiation to that? And was it for mathematics and science were so advanced? I'm sure there must be some written records and calculation, like we have the Babylonian tablet that has, Pythagoras theorem, and because this time period is also, we know it as the Harappan and Indus Valley civilization time period. So how do you connect it with that? And so a lot of the oral stories that you've interpreted from the Puranas, I just wanted to ask, these can be very liberal interpretations as well. So I just wanted to ask, are there any, written records of mathematical mathematical calculations that back these up.
Skepticism is what allows us to explore and investigate our theories and get the correct answers. To start with, I recommend you see the paper by K.N. Dikshit from Deccan College, Pune. And he's got a paper maybe in 2015 or 16, I don't know the date, but it's a nice compendium of all the radiocarbon dating that has been done on the following sites in Mehrgarh, in Birana, Rakhigarhi, and one more place, I forget the other one. So they're given tables of calibrated radiocarbon datings. In Birana, like I said, the oldest one goes to 9,000 years before present. In Rakhigarhi, about 6,000 years before present, and so on and so forth. The point is, if you're looking for archaeological dates that are that antiquity in India, you will find them in a lot of places. Let me give you one more example. The National Institute of Oceanography in 2003, in episodes, they brought out a paper, and this one was by a team that was laying a submarine line in off the Gulf of Cambay. So they found in sonar dating a 9-kilometer seawall. Additionally, they found a piece of wood, they dredged it up, and they did carbon dating of that wood from that site. And that was done in Germany and in Hyderabad. The dates came to about 8, 9 something, about 9,000 years before present and so on. This is what we traditionally say is the region of Dwaraka and so on. We can't identify it as Dwaraka, region of Dwaraka. Then the work of Professor Ramaswamy from Bharatidasan University. He's published it in 2020, 21, I forget exactly when, but he's done enormous work in Poompuhar. The Poompuhar that you know today is in the east coast of India, the Bay of Bengal, the capital of the Cholas, and they used to go maritime trading from there. But he's not talking about that. He's talking about the Poompuhar that is submerged in the Bay of Bengal, 15 kilometers from the present day shoreline, 125 meters depth. At the time of the last glacial maximum. Last glacial maximum was an ice age 18,000 years ago, when most of the water was locked up in ice. That is when the shorelines are visible far beyond where they are today. At that time, he has found settlements over there with man-made harbors. That is an amazing thing. It's so fascinating. I don't know what to say, because 18,000 years, 15,000 years ago, if there are man-made harbors over there, that means people are going by ship or boat from place to place. Now the question is, how did they make those boats? There's no iron technology those days, just with coir and other such things. There's so many things can be derived. Who were they trading with? What did they trade with? Was it barter system? Were there coins? So many questions come when you look at the data like that. So if you're looking for archaeological information, yes, there is a lot. And very, very unfortunately, the historians in this country, they don't want to interpret the archaeological records. You may want to read the works of Dilip Chakrabarty. Dilip Chakrabarty is in London. He's an archaeologist, and he laments that the historical narratives are far behind what archaeology has found. Historians believe they are best suited to interpret archaeological finds. Archaeologists say, on the field, I know exactly what is there. I am better prepared to do that. I'll give you one example of the absurdity of this. In Sanauli, not far from here, they found these chariot burials. The archaeologist on duty, Manjul, or I forget his name exactly, S.K. Manjul, I guess, he had a video, Warriors of Sanauli. In that, he emphatically claims that these were horse-driven chariots which date back to 2200 BC, before the Aryan invasion. But do you know what Witzel wrote about this? Witzel, Romila Thapar, Razib Naik, they wrote a book recently on this. Witzel says, sitting in his room in Harvard University, that these were bullock cart-driven chariots. Am I going to trust an academic sitting in a closed room over there, or the field archaeologist? Thank you, I'll go the field archaeologist. He's got the data and he knows what he's doing. So the issues that I'm trying to point out is historians are not up to date on archaeology, and if it does not fit with their standard theories, they put it in the back burner. They don't really deal with it. That is one. You asked about another thing about the writing. You said Babylon, you have cuneiform writing that shows a whole lot of computations. Do we have that in India? Very good question. In Babylon and other places, you have semi-arid conditions. If you were to go to all the Persian Gulf and other places, we're not talking 50,000 years ago. It was green that time. We're talking about 6,000, 5,000 years ago when it was dry. So over there, the mud preserves for a very, very long time. In India, is a tropical country with monsoons. You don't have medium that can last. These are all perishable media. The ones that can last are engravings on stones and things like that. And we have some. We have the Dholavira signboard. We have a few things here and there and so on. Next, you talked about how it is only Harappa that we know in this time frame and not elsewhere. This is because of the fake periodization imposed on Indian history. Our historians have imposed that we had a Harappa period, followed by a Vedic period, followed by a Buddhist period, followed by a Muslim period, followed by something else period, and so on. This periodization is specious, and we have it on the authority of B.B. Lal, who passed away recently. B.B. Lal, throughout his life, has worked on Harappa and other places. Early on, he made some statements, but much later on, he said, you know what? There's a cultural continuity. There's a continuity in the material evidence across the spectrum. There is no Harappa period followed by Vedic period. He's saying that you have the Pashupati seal over there in Harappa that is showing a proto-Shiva and yoga asana position. That is one. He's talking about the terracotta figurines of women showing the sindoor. Even today, married women wear sindoor, cultural continuity from Harappa. He's talking about a swastika symbol. Swastika symbol is there in Harappa. It is there even in India, even today. It's one of the auspicious symbols over there. He's talking about several other things. And my favorite one was a paper that came out last year in Journal of Archaeology. This paper came out, talked about finding 7 footballs were found in a desert in Rajasthan associated with the Harappa culture, made of moong and other such things, along with other figurines, bull figurines and other things. So they tracked it to some kind of a religious entity. And I said that even today in India, we do Pindadana, ancestral offerings when we give footballs and things like that. In this case, luckily, it has become fossilized and we have it to analyze. So we are seeing cultural continuity across a layer. Periodization is faulty. Even in the pottery record, you don't have periodization. There is no period you can say the Aryans came into India. It's all a complete mess over here. So many of the assumptions that you have is because of what we learn in our textbooks. And I am all about challenging these things, and I'm challenging these things with evidence. So the reliance on archaeology, on writing, it is good, and you must have that. But the reality of our civilization is we don't have that. And let me tell you that even when the Muslims learned number system from India, they learned after Bin Qasim's invasion, started learning. Do you know what they called it? Al-Gobar, which means writing in dust. Indians were writing in dust and sand and so on, the numbers. They learned it, they called it Al-Gobar. So is it a medium that's going to last? We have found the Saraswati Sindhu settlements. I don't know if you've had a chance to look at the satellite imagery showing where Saraswati used to flow. We have several settlements all along that. Today there's no water, but there's settlements over there, which is showing you how ancient some of these things could be. But anyway, go on.
Yeah, I agree with that. So my thing is that to have a substantial change and even academically to challenge a lot of these notions in historiography, I do feel we also need written records of like mathematical, because there were people surely living there in settlements, but how do we prove that those people did these calculations?
Vedanga Jyotisha, 1400 BC, we have got calculations over there. Parashara Tantra, we got mathematical information. Surya Siddhanta, enormous amounts of mathematical information. Aryabhatiya, tremendously a lot of mathematical information. Going on to Bhaskara, Varahamira, Bhaskara the first, Brahmagupta, Bhaskara the second, Munjala, you name it, all through history, we have got people who have been working on numbers, writing it into books, palm leaves and things of this nature. So we have that.
Actually, you already know about the situation in academia. I feel, the ideological and political interference is a bit too much that you don't have much intellectual freedom. So I just wanted to ask for students, who genuinely want to explore these possibilities and want to have a look at Indian history without being deracinated, with an objective view. How do we go about it? How do we access primary sources? I'll share an experience where I tried. Like, you also had one presentation where you were talking about planetary diameters and how some of the mathematical diameters are very similar. very close to modern estimates
Right,
we
right,
have
right.
today. And I remember I had this Kitabul Hind project in my graduation time, and we were supposed to do that in-depth analysis of two chapters. And one of the chapters, there were mentioned, like there was mention of diameters, of planetary diameters, and I was very fascinated by the fact how close they were to modern calculations. So I wanted to see, what are the sources, like because if we had such advanced mathematics and sciences, there must have been a sort of rigorous academic system there. There must have been a lot of texts where, these things were written, and but in our historiography, we don't know about that, and we don't read that, and like we don't know
Okay.
how to explore
I
that.
get it. You need to attend my classes in Hindu University of America. It's an online class. I have students from Delhi joining that. Please do join that because we go through epistemology, we go through the darshanas, we go through the knowledge systems in India, how it evolved over time. Comparatively, we see what did the Babylonians know, what did the Chinese know, what did the Mesopotamians know. Looking at it comparatively, you'll get a fantastic idea what your ancestors were capable of. You correctly said, based on the earlier talk I said, historiography is the issue. 5 forces today, and they're all inimical. They're against the Indian civilization because of their ideology. They have written the history of India. And you're reading that, and unfortunately, if you read that, you will be deracinated. And this is the kind of narrations that we have. But the questions you ask are absolutely right. Everybody must demand the evidence. We must ask for the evidence, but must not be too hung up in saying written evidence. Because if you say written evidence, you're doing a great disservice to the Indian civilization. Do you know why? Do you know why? The written record, in the popular way that we look at history, history starts when writing is there. Prior to that is prehistory. If you don't have writing, it's prehistory. Very ancient is proto-history. This is the periodization that we do today. The word was very important in the Abrahamic tradition. God gave the commandments to Moses in stone, right? So the written word has assumed great importance in the Western, the Abrahamic cultures. In India, we had an oral tradition for the longest time. People discount the oral tradition because you can say anything and get away with it. But do you know in India we had something called pathas? Very pathas are ways of chanting a certain mantra that you say. You say the first syllable, second syllable, second, third, fourth, fifth, and so on. And complicated formulas are there to do that. This tradition is there in the southern India. I'm not sure if the tradition is there in northern India, but it is there in southern India, very, very strong tradition. What it means is, to me as an engineer, it means there's an error correction mechanism. Today, when we do cellular telephony or communication, we take care how do we transmit the error so that the error can be fixed at both ends, that kind of a thing. Very similar over here. Because of the way you do the chanting, there's virtually no error or even in the way that sound is made. So if you hear an authentic Vedic scholar chanting some of these things, it is how it would have been maybe 10,000 years ago. It's exactly the same. So we do a great disservice to our civilization when we say written record only, because we are a civilization that has exalted the oral tradition in a manner that no other civilization has done. So we should be deracinated to the point where we can realize this and say, look, as far as the Shruti literature is concerned, these are all transmitted exactly. Smriti literature, yeah, that is different. The written records and other things. Shruti literature, we know it is as accurate as it can be.
So, when we are talking about in one of the lectures that you had, you also mentioned about the astronomical dating going back as far as 25,000 years. That's right.
In one of them I did, yes.
Okay.
Yes.
Now, what is curious for me is, for sure, when we are having a think tank, I'm creating them, it's either think tank, those rishis are think tank who are creating astronomical propositions. For sure, they must be accorded to the position because there is a kind of a clear demarcation that the society is already having. Okay, so there are people who are creating the surplus and then leading them to create such a kind of propositions. And making an assumption over here, this for sure has to do with the agriculture. Now, the oldest possible record that we are having as of now goes back to 13,000 or 14,000 years, not more than that. So, does it mean that the established notion that we are having, that agriculture or the trade that started, is also wrong in the contemporary understanding that we are having? Even that could be even longer than 30 or 35,000 years as well.
So that assertion that you made of 13,000 years, where did that come from?
That's records that have been available online. That's oldest available agricultural records that we are having
Okay.
in the form of
Okay,
tools.
so the accepted one is Turkey is where agriculture was around 6,000 years, 6,000 BC, so 8,000 years ago. But in India, we got the work of Singh, B.N. Singh, and a couple of other authors from Lucknow Paleo Institute of Sciences, where they came out in Current Science. I think that's a journal. In 2018, they came out with a paper on paddy grown in Lahura Deva plains. So they are talking about wild paddy as well as cultivated paddy over there by analyzing the diatoms and other such structures over there. They say from the Holocene era, we've been growing these things. Holocene is about 12,000 years or so, but the data in the paper, if I'm not mistaken, shows from around 9,000 years. 9,000 years in the Ganga plains, we've been growing paddy. That is the data that we have. So if you're looking for published data, this is what it is. Can it be older than that? Maybe. But we don't have evidence of that yet.
Question number one is, do all of you people or a large body of people working in similar viewpoints, do you collaborate? Is there some way of putting all your data points together in time and place and examine each other's, kind of peer review each other's data points and interpretations?
The researchers today have the burden of the Indian civilization, individuals all over the place. And so they tend to work alone because they have a day job to support them. There's no institution where they have a sabbatical where they can do things. I have a day job as an engineer. So it's difficult to form collaborative associations here in a situation like this. So it has precluded people from coming together and working together so far. But we do have conferences. The WAVES conference that just got over in Delhi in December, January. That's an instance where people can come together. But conference formats are also not the best thing possible. So we need a format where people can come together, discuss, maybe duke it out and all those kind of things. But such a forum does not exist today.
So there's no way to put all the data points together and sort of.
I would ideally like some kind of Indian institution which says, you know what, we're going to design a 1 month long retreat in this lovely place over here. We've invited all these people, and every day we're going to sit and work.
Okay.
Now that would get some results, but I don't see anybody like that coming forward. My preference is Kodaikanal or Ooty.
So this is quick to say because right now the data points and the claims or the interpretations are so way off that they tend to be laughed off. There's somebody like Nilesh who telling us one date, let's say 12,000 BC, and somebody comes with a date, it's 1200 BC. So there is no really speaking a sharp point to basically counter a different variable.
See, the researchers are very active. Nilesh has done a lot of research. So he's not simply putting something out there. He's doing a lot of research and based on his insight, he's written something. At the same time, he's got a lot of critics. There are people like Rajaram Mohan Roy. There are people like Jayashree Sarnathan and others who also criticize what he's done. They try to see what did this man say, what did he say here, what did he say here, is this right, is that right? So there are people also giving counter viewpoints. So I think we have a robust research environment, even if it appears antagonistic by deriding each other's work and becomes a Twitter war, and before you know it, there's all things flying.
Like what the young lady said, there has to be the other sciences sort of correlating all the data together. Like you mentioned yourself. So that's question number 2. Is anyone done devil's advocate with, okay, let's say whatever theories these historians come up with, and say, okay, if you are in a place like there, Labels or some other place, and you have this kind of data or this kind of thing, what would it mean in terms of time space? So like, has anyone done like a
I think most researchers are at least cautious. They test the data. They try to see alternate viewpoints, alternate explanations. I try to do that myself often.
If you take the same statements and assume for a minute that it's located in the steppes or Anatolia, and what kind of time frames one comes up with. Has anyone tried that?
It's too hypothetical to answer. Too hypothetical. But the point is that do we test our data? I try to do that. I try to see, is there an alternate explanation that fits it? If so, disclose it and say this explanation also fits it. I think that's intellectual honesty. At least I try to do that most of the time.
That's what I should have been
Right.
in every way.
Right.
Sure.
Right.
What's your plans? If we ask of putting all data together in a series of, documented lectures or books, which is
I'm hoping to. This is one thing I've been asked in every talk when I'm going to write my book. And my good friend Pramod Buravalli says, I'm the last Hindu intellectual of the time who's not written a book. Everybody else has written one. But I have a day job, it's tough. I'm trying.
Even a series of lectures, I think that would probably work. Very organized.
I've been giving series of lectures. I offer a course now, 2 courses at Hindu University of America. So there are 20 lectures of 2 hours each. There's a 40-hour duration. I'm offering the same thing in Rishihood University starting on February 5th. That is the day after tomorrow, all the way to February 10th. So if you're interested, do contact Professor Samadhanand Mishra and join him.
Thank you.
So 40 hours of instruction.
Thank you so much for a nice lecture.
Thank you.
My question is, most of the stars' name were taken, put by the Arabs or Greeks. I think with hardly 1 or 2 are having an Indian name. So how to force that International Astronomical Union, which names all the stars, new stars and the planets, to put the Indian name?
So this is exceedingly bad parochialism, like you said. It exists. Their vision of any sciences is it came from Arabs because the transmission to Western knowledge systems happened through Toledo and through Sicily. That is where the Islamic empire, the Abbasid Empire was over there, including southern Spain, all that. And they had got a lot of translated Sanskrit works, translated into Persian and Arabic, injected into Western Europe, into Latin text, translated. So their idea of science has come from Arabs. So they use Arab names and they use Western names. So their idea does not go back, their thinking does not go back to India, the original source. So it's parochialism, ignorance, both combined over here, and Eurocentrism, a lot of Eurocentrism. So if you look at the names of all the planets around, the satellites of Jupiter, satellites of Saturn, they all have Greek names.
Yeah.
Very, very few of them. One of them is called Rudra. Very, very, very few. As of like an afterthought, there is a footnote over here. Also, one Indian name over here. So the sense of grandeur, the sense of accomplishment is simply not acknowledged or known in the Western world, and they control the institutions, unfortunately. So there's no way they're going to come out and do what you would like them to do, because their response will be the same. Our textbooks say this is a young civilization. You copied from the Greeks after all. So we got the Greek names. Unfortunate. So we had to fight a lot.
So I'm Surya Roy. I'm from ATAC and ICOMOS. I don't want to put any question. I want to share information, particularly for our young friend. Talking of continuity that you touched upon, and the Indus seals, on the Pashupati. So there is a particular Indus seal which has a strange animal, which is a combination of 9 animals. And this particular seal was again mentioned by Sarala Das, who wrote the Uriya Mahabharata in the 16th century. And even before Sarala Das wrote the Uriya Mahabharata, the current Jagannath temple that we see, and the Nila Chakra, the Sudarshan Chakra, which is here, the Nila Chakra has this creature, Navagunja, on it. So the question is, coming to continuity of, as you rightly said, Indian civilization, right from Harappan time, is truly a continuity, and the best way to explore is get down to the soil.
Right.
Go down to the field, visit the sites, and you will come to know many things which are not quoted by any scholars, stuff which you will not find on any books. India is that antique. And coming back to the Turkic mention of agriculture, if you read our Puranas, you will see that agriculture actually started in Kurukshetra, Dharmashetra Kurukshetra, and that is why. If you read Krishna Daipan Vedavyas's Mahabharata, it clearly mentions why Bhishma then, the conversation between Bhishma and Sri Krishna, why they choose Kurukshetra as the battlefield, and that is because from Maharaj Kuru, who was the initial ancestor of the Kuru dynasty, and the boon that was given on the land of Mahabharata or the land of Kurukshetra anybody passing away over there will get bloodshed. And that is also one of the reasons, if you read Mahabharata, Sri Krishna and Yudhishthir, Samrat Yudhishthir, performs the Prindadan of all the 4 million people who passes away at Fewa. So Fewa is one of the places where he went to Prindadan. So I just want to, corroborate on the points that Professor Dr. Raj Vedam has mentioned to, particularly emphasize on the fact India stays on the ground, travel on the ground, go to the sites, and you will come to know many things.
Yes,
Yeah.
Thank you. So, very interesting to read the works of Parjita. Make a note of that. F.E. Parjita. He was a British judge in India. Parjita, P-A-R-G-I-T-E-R. Parjita, he was a British judge in India in 1920s. And true to his profession, he wanted to examine the evidence and make conclusions based on that. So he writes, at a time when everybody was talking Aryan invasion and so on in 1920s, he writes, the Indian historical tradition knows nothing of any invasion. In the Indian tradition, the sacred sites are not in northwest India, but in Varanasi in the east. If the Aryans had come through northwest, we expect sacred sites to be there, but the sacred sites are over here. Then he goes on to present a lot of evidence that is contrary to the Aryan invasion, and he asks a very important question. He says, if these are all forgeries, then who created these forgeries and in whose interest? Is the entire Indian body of work wrong? So in my talks, I always present one sheet. That one sheet, I've got a table of about 100 Indian names, whether it is from Abhinavagupta, Agatya, Andal, all the way to Vishakadatta, other people, to Yajnavalkya. And I ask this question, in this huge list, who is talking about Aryan invasion? Who is saying we are North Indian, South Indian? Who is saying that we chased these guys from the north and they went to the south? Or in the south saying we used to live in the north and we have come to the south? Not one text has got any cultural memory whatsoever of an invasion, fight, 2 people, so on and so forth. This is the evidence staring at us in the face, right? We've got so many, whichever geography you take, whichever timeline you take, there are writers from there. Show me where there is anything. So we ignored this copious tradition that we have. And 200 years back, somebody put into our heads that Aryan invasion, 1500 BC, and we have lapped it up completely.
Hello, I'm Arvind Tripathi. Just one question out of curiosity. So this software that you use for astronomical data and likewise OAK and others, are these similar, same, or like you use different softwares, but how do you know like which software is the best one, or how do you know about that?
Most of the software are front ends on a mathematical engine that I call VSOP 87. That is updated. There are different editions that come. So the commercial packages that give you this planetarium software, you have to see what is the update that they have and what are they doing. The updates will not give you vastly different ones, but they fix a few things here and there. Many of these are based on algorithms by a man called Mears, John Mears, I believe. John Mears. I got the name wrong. But he's got a book on astronomical algorithms. Those are the ones used to approximate the proper motion of stars and all of those kinds of things. So that is a software that simulates going back in time. Otherwise, how would you do it? If you had a multi-body dynamical equations, nonlinear dynamical equations, you'll be solving forever. So that's why we have correlations. These are all correlations, polynomials, and so it's error in everything. So bottom line, I never try to pinpoint it to a certain day. Most of the times only when did winter solstice happen, when did this happen. Error could be up to 2 years, 5 years, 10 years, doesn't matter. The time scale that we're interested in, 7,200 BC, a few years this side and that side, really doesn't matter.
So my question is, like there are sometimes gaps in probably the whatever narratives we have and whatever the observations. So can we say that maybe in future we will come to know in those softwares that this will be updated and it will probably explain. Can we reverse sort of project on?
I'm interpreting your question as the paradoxes that we have in astronomical dating. There are several paradoxes. I'm interpreting it as, can we resolve those paradoxes in future updates? I don't think so. Paradoxes could mean interpolations. somebody in some period of time has written something that doesn't fit into this record. As an example, if I give you, if you see the Ramayana, you'll have to now say consistently Rama's birth date. I have the chart over here. I can tell you this is the year of his birth. Then you must say, when did he go away to Vishwamitra's ashram? When he was a teenager. I can tell you that date. Then Sita Swayamvaram. When did that happen? I can tell you that date. Sita's abduction. Hanuman's jumping to Lanka. They should all be consistent in the sense that the number of years can't vary too much. You can't say, I've got Rama's date in 5000 BCE and his coronation, I've got it at 1000 BCE. Because that's a star positions. Clearly, there's a problem. So those are the paradoxes, and we do have paradoxes. I did a study several years ago, maybe 5, 6, 7 years ago. I took 4 claims on Ramayana, and I said, I'm only going to see, based on Valmiki Ramayana, he has given the star positions for Rama. Based on that, can any of these people who made the claims, can they fit it? And I found that not a single person could fit that date. And for good reason, because this one says Ramayana is in Treta Yuga. We are trying to fit it in 5,000 years ago, 4,000 years ago. So we have problems, we have big problems. So one has got to be careful in any of these things.
Hello, my name is Bharat Sharma and I'm a student of linguistics at the university. So there's a phrase in English, the language we all love to learn but are unable to. After all, it's a foreign language. So there is a phrase that goes lost in translation. So don't you think a lot of knowledge that we try to acquire is lost in translation because we are trying to explain and learn everything in English, whether it is about our knowledge systems, about our science, about our Vedas, everything. Whereas the knowledge that really lies was necessarily and what we call Devvani. It was in Sanskrit. And don't you think there was a conspiracy that was pushed down our throats when you say it was we were mugging up English and the English systems, and we were so into it that we were not able to. We made a distance. We made so much disconnect with our own language. So don't you think that was a conspiracy by the foreigners that we got so distant from our own source language and in which we had so much knowledge?
Yes, let me address the second question first. Yes, that is correct. In 1835 or 36, that's when the English Education Act came about. If you see my talks, I'm saying the British practiced ethnocide in India through 5 mechanisms. And that ethnocide resulted in enormous poverty and turmoil in the country. Around that time is when Macaulay, he came with this English Education Act. As a consequence of that, they would not give any money for Sanskrit or Arabic or Persian. All money was to be used only for English education. So they made a disconnect right over there. Indians were alienated from their own systems and they could not connect to their roots anymore. All the way from 1835 onwards, we've been having this kind of thing happening. So the second part of your question is, yes, it was a deliberate move to remove people from the Vedic thinking and to make them more of clones of a Western way of looking at things. They wanted to do that. He says it in his own writing, will make them English in thinking and so on and so forth. Now the first one that you asked, I forget, what is the first part of your question again? The translation, lost in translation. Yes. So it's critically, you're right, it's critically important not to read translated works. If we can have Sanskrit works, it is good. This is what Rajiv Malhotra calls non-translatables, Sanskrit non-translatables. You should not use that because the cultural context is lost. Because the language is a repository of culture, history, knowledge, everyday happenings, and so on. Only when you embed it within that system, then knowledge, the context is clear. If you remove it and do a word-for-word translations, it is gone. In fact, I have a paper on this with Sitaram Ayagiri in the WAVES conference a couple of years ago. We took a couple of translations of Ralph Griffith on Rig Veda, and we showed the absurdity of those translations. For example, he's got a verse that says, Indra twirled his yellow beard. And this was taken up by a lot of Marxists saying that this proves that Indra was a European who came to India, blonde guy, and all this kind of things. So we try to take Sayanacharya's interpretation, Rangacharya's interpretation, and Sitaram Aiyagiri is an excellent scholar. So he came and said that, no, this has got a completely different meaning. Bottom line, we said, in order to understand Vedic literature, you must be an expert in Vedangas. You must be an expert in all the Vedic literature. Then you can make an interpretation. Vedic verses cannot be translated. Word for word translations are meaningless. It's got to be interpreted all the time. And obviously, that means that multiple interpretations might be there. That's why the context is critically important. Have you got the context correctly and interpreted it correctly? So I hope that addresses what you said. Thank you very much. Thank you.